cat interviews at Uber, Confluent, Indeed, and many more companies. I've seen it all. After countless hours on the other side of the table, I know exactly what top companies are looking for, especially in LLD. In this course, I'll share the insider blueprints, what to focus on, especially key design patterns, how much multi-threading, very important, counter question, traps, and how to tackle them confidently. This course is structured, practical, and tailored on what companies are looking for right now. Let's get you interview ready right now. Okay, so in the last lecture of our low-level design course, we saw about what is LLD, how to approach LLD problems in an interview, and some of the most important interview tips. In this, we're going to see entirely about OOPS. This is going to be your OOPS crash course, which will cover very basic introduction to classes and objects. Then it will cover a class relationship diagram where you know different types of arrows and all that stuff. Although if you must have seen the previous video of LLD, I told you it is not important to make this in an interview, but it is important for you to understand any of the future class diagrams. Now we'll learn about constructor and its types, this keyword. Then we will cover polymorphism, encapsulation, abstraction along with their interview questions. Because many a times same things have been asked to me in an interview. Also, whenever I take interview, or I also ask the same about OOPS. Specifically, people think it's easy, but they end up screwing up one way or the other. Then we will lastly learn about access modifiers and about generics and wildcards. Now, this you might see, Aryan, it's overkill and you know it's pretty much high level. No, it is not. It is actually important. Starting off with classes and objects. Now, as you all know, that basically OOPS is nothing but it simply says that I will use a programming paradigm such that I organize my code into some objects, and the biggest benefit is that these can be some real world entities, and ultimately any complex system will be made smaller, manageable because of using OOPS. Now, basically, how does OOPS do it? OOPS do it with the help of classes and the corresponding objects. Now, the biggest thing is, okay, how? Okay, before we go on to how, just a quick thing that it will help us to make things more structured, more reusable, and more scalable. And we will see as we go on through it. For example, we will take a simple example of taking or generating or producing cars. Now, obviously, when you generate any car and you know that you have to repeat that process again and again. So obviously you will design a blueprint, a specific set of steps, instructions, or guidelines, or something which can be reused again and again. That reusing of thing is can be called as a blueprint. Now, this blueprint specifically in terms of car can define a structure and the functionality of a car. Same way for any specific future operation, if I think that things can be reusable, which is primary one of the very important demands for us, I will make a blueprint of it. And that blueprint is nothing but called as a class. So class, which is a blueprint itself for the cars, will be the actual class. And the actual cars which will be made out of this blueprint will be the actual objects. So let's see what exactly is class. As I mentioned, that class is nothing but a simple blueprint which will define the properties and the corresponding behavior. Properties as in attributes. If you see any class, as you can see, a class is given. Car is a class here. It has some attributes. Attributes as in some properties. They say, okay, what is what all things I require and what are the specific attributes of this specific class. Then I will have some methods which say behavior. What will this specific class can do? This car class can start an engine. It can display the info. These are the specific methods. Behavioral, what I want the behavior for it to be. And again, making sure that this defines the structure and the capabilities of an object. But it does not represent the actual instance. It's just a blueprint, just a thing, what could happen. What will actually happen, we will see it. And again, just to complete this class thing, we know that we have attributes, we know that we have methods. There's something called as a constructor as well. Now, the best part of the constructor is that it helps to initialize the attributes just in the very beginning, whenever the object is created. Now, what is object? Let's see. object is nothing but an instance. Instance as in a child, you can say, of a specific class. As we saw previously that a class is nothing but a blueprint. So the actual thing, actual rigid thing is actually called as an object. Now, the best part about the object is as we are making it from a specific blueprint, so these objects can contain different set of data. And that is the reason they will contain some unique set. Again, they can be same as well, but the best part is that they can contain any unique set of data. You will see the help of example also, but imagine that you have any car which we are taking as the previous example. I can have a different year, model, or even brand for that specific instance of a car. Now, same way as what we saw that an class has some attributes and stuff, same way you will see that here the car1 is actually an object. Car was its class, or you can say blueprint, but the car1 is the actual object. And the best part is the data can be anything whatsoever. And that is the beauty of an object that I can use with the same blueprint of car. I can use any set of data with it. And thus, whenever I will call any methods, now if you remember what are methods, so basically this is a constructor, and the attributes inside the car1 will be its corresponding attributes, and these are the methods. And the best part is that both car1 and car2 having the same method, but the output will be different. Why? Because their internal data are different. And that is the reason you can easily understand about cards, about objects and your classes. Now, as we were taking the real world analogy, just continuing with that analogy itself of taking cars itself, that design and functionality of a car is actually called as a class. Okay, I gave it some attributes, I gave it some methods, it's a functionality which I gave it. Now, how will every individual car implemented goes to it? And it will never represent an actual car, because actual car will have its own specific things which is very specific to it. It can be a color, it can be manufacturer, it can be model. It will be very specific to a car. For example, this, let's say Hyundai or like Honda. Now, obviously, it is a red car, Hyundai i20, lead engine is different, and like petrol type. Again, this I have kept it very few items, but you will see that this is one set of data. Another set of data can be Honda, engine capacity, and the diesel. Many things can also be different. Same way, you will see with one set of blueprint that okay, what is the color, what is the brand name, what is the engine capacity, and what is the petrol type. Whatever I mentioned, color, brand name, engine capacity, and petrol type, this is what I can actually say as a blueprint. And again, this is defined as attributes. It can also have the corresponding methods. Methods is behavior, drive and stop. A car will drive, a car will stop. The same behavior can go and can be extended to drifting. Let's say a car can drift, the bike can also drift, but a plane, yeah, it can also drift. So again, but these are the behavior what a specific car can do. Now, as an ending note, just to give in a one line, a class will give a structure and design, but the actual object will bring that structure to life by some specific set of data which is unique to that specific object. And the best benefit is it will be modular, reusable, and scalable. Again, why modular? Because obviously it will be clean and using the same set of blueprints, and scalable because I can make different such objects, and you will see in future that I can reuse some set of blueprints again and again by just extending it, implementing some things and all that stuff. Cool. Let's go on to the next lecture and we will go more deep dive into OOPS. Okay, let's continue further. So in the last class and object discussion, we also saw something called as constructor. Now in this video, we're gonna see about constructor and its types and also very important interview questions. Let's start off by simply seeing that what is actually a constructor. Now it is used to initialize basically objects of a specific class. As we told that class is a blueprint, object is something which is actually an instance of it. Having something concrete to it. The best part about constructor is that it can help to give a valid state just after it is created. Now, why it is required? It is required because obviously if you have some blueprint, if you make some object to it, you want it to be, good. At least as a starting point, it should be good. Obviously, you will put some data into it, then it will become okay. Now it is something, okay. This object means something, which is after you will put up some data, which means, adder, getter, a simple headers can be helpful to put up some data. But then if you miss this step, if anyone looks at the object right now, then you will not see all the data which you have ingested or you have put up, if anyone looks at this step. So it is recommended that if you know that, okay, just for that specific object, if you want to give a valid state just when it is created, then we use a constructor. Now, the best part about constructor is that unlike the normal regular methods which we have, which we help to put up some things inside my object, constructor have the same name as the class name. And obviously they do not return anything because it is used to only set some values onto my object and nothing else. And just so that it is uniquely identifiable, it has the same name as the class name. The very important key features of the constructor is that it is automatically invoked. As soon as I make my object, it is automatically invoked. And that is the biggest strong point that why a constructor is needed for any specific class. And as we saw that it is just to put some values, thus it has no return type. And also there is some overloading support to it. We will see what that support is, but the entire essence is that I can have same name constructor. Again, if you know the name of the constructor is the class name, but obviously parameters will be different. No worries if you don't understand this, we will discuss in very deep also in the future sections as well, but this is one of the properties of it. Now, the other best part is now you will learn about some of the very fundamentals types of our constructor. Again, we have default constructor, which is also called as a no argument constructor, as you can itself say by the word default, which means it is automatically made, automatically invoked, and has no argument. For example, you will see that, okay, I have a movie class, right? Remember the class from the last lecture? In that, I have nothing. Now you might say, Aryan, nothing? Then where's the constructor? That is the reason it is called as default. Which means that if you have any class, automatically you will have a constructor as well. Now, again, this is automatic. This is not visible to you. It is internally in Java. This is happening at the backend. What will happen whenever you are about to create an object? Again, I'm hoping that from the last lecture you remember that movie. Now, this movie, it can be movie 2 as well, it can be any name. This is actually an object. So this object is being created and I create this. As soon as I create it, I call a constructor, and that constructor is movie, which is not visible here, but is automatically called. And now you might ask, Aryan, if it is called, then you told in the beginning that the constructor is used to initialize things and give it a valid state. So if it is automatically initialized, what is the state of the attributes which I had? So this will give default constructor will give default values. For integer, a 0, for double, a 0.0, for boolean, a false, for object or maybe string or anything of that sort, it will give null. In this case, title is a object, it's a string, it will give a null. For duration, it is an integer, which is a primitive value, it will give a 0. That is the reason this default constructor will give a 0 and a null here. So when you call this movie, this object is being initialized with these default values. And thus my title will be null, duration is 0, because I'm now calling the display details. Display details will call this specific method where I'm printing the corresponding title and the duration, and it is being printed as the default values. Now, you might say, Aryan, what is the use of this? Obviously, yes, there is no use of it because we can explicitly define the actual constructor, which is, that I have the same movie constructor itself. This is called as a custom default constructor. Obviously, you have a default constructor which you already have. It's just you have changed this one. Change this one, and now you are putting up, okay, title is no more null, it is defined. Duration is no more null, 0, or it is no more default value, it is defined. That is the reason when now you will print this, you will have these default values. Title will be untitled and duration will be 90. So again, I'm calling the same default constructor, but now I have defined it as a custom default constructor. That is the reason when I will print it, it will give me title and duration. So what is the benefit? Obviously, the main point of constructor was to gain control. And now I have a control on how my object is being initialized as it is being made. Now, this is what the benefit is, that you will start off with some meaningful but some default values. Now, you might ask, Aryan, if I don't want the default values, no worries. You can give actual values itself, which is parameterized values. So, title and duration, I will give it right now. And with this title, whatever I'm giving as a parameter, as you can see, it's a custom parameter, which I'm giving the actual parameters. So title is being, so this input title of a class is being, put up as this title, and same way that this is the duration which I am putting up. What is the benefit of this? Obviously, you can see that now when I'm defining an object, I can give the corresponding values. So inception will go as a title and duration of 140 as a time will go here. Thus, when now what happened? My object has been initialized with these two values of inception and 140. So whenever I will call any method of that object, what will happen? You will simply print the title, which is now inception, and you will print the 140, which is the duration. And this is what you will print. Now you might say, Aaron, okay, this seems pretty good, and I guess it is completed. Maybe, but you will see that you have another thing, which is the copy constructor. What is this now? Now you might say, Aaron, copy. Obviously, the word itself says copying a constructor. Now, you will see in future, I will discuss about shallow copy and deep copy, but no need to worry about anything. Everything will be discussed in future as we go on to multiple sections. But the copy constructor says that rather than having the actual parameters, I will give you another object. I will give you, you just copy that specific thing. So what I give? I give another object to you and just simply copy it. Make a copy of it. What is the benefit of this? Obviously, if you remember that you have an object original, you defined, with some custom parameters, you define that object. Now you have original object. Now you want to make another object, but obviously with the same values. If you do something like this, movie copy is equals to original. If you do something like this is what you're doing. You are just passing the reference, which means copy and original are both same. It is not another object being made. No, another object is being made only by the new keyword. So this is, if you do something like this, it is, you are just copying the reference to it, not exactly making a new object. How to make a new object then? Obviously, call a new method. But then are you saying that I have to remember all these parameters? No. Now, whatever existing object you have, just pass it here. And then in your actual class, make sure that you have another constructor which can, accept another object and say, okay, other title, accept this title, another other duration, accept this duration. Thus, a new movie object is made, which is called as copy, and it has copy of all the data of original. And that is how my copy constructor works, right? Make sure that now if you modify and say that copy title, I modify it to let's say any movie, let's say Inception 2, then original will not change. Original title will remain Inception, copy title will become Inception 2, but it will not change. But if you would have done something of this sort, that movie copy is equals to original, if you would have done something of this sort, then if you modify copy and say, okay, copies title becomes Inception 2, then because it is passed by reference, original title will also become Inception 2. That is the reason you use a copy constructor. Now, obviously, as you can see, that this is the output from a copy constructor. Now, you might say, is it completed? No, it is not. Just quick thing that we also have private constructor. Now, what that is? Okay, constructor we have, make it private. But Aryan, although we will discuss about all the access modifiers in future, but again, constructor is very basic, so we discuss it right now. We'll discuss about private and all that stuff in future as well. But just for the folks who don't know, private helps us that, okay, no one outside the specific class can access it, which means that I can now no more call this constructor itself from outside. But Aryan, if you will not able to call it, then how will you initialize the class? That's the, initialize the actual object. That's the biggest question. That's the main thing. That this private constructor, it restricts the object creation, which means that outside of this class, I cannot initialize this specific object. But Aryan, this doesn't make sense because constructor's duty was to initialize the object outside the class. And you are saying that making it private is actually making it not do it. How does it even make sense? Yes, that is the reason it is used in singleton design pattern. Although we'll discuss this design pattern very thoroughly and we'll discuss that in a multi-threading way as well. But the best benefit is when I decided to have this constructor, which is singleton, as a private, which means that no one from outside can call and can write something like this, new singleton. New singleton. No one can do it. No one can do it. This cannot be done. Then the question will be, then how will I initialize my object? Then you will say, I will make a method. I will make a method which is get instance. And this get instance will check if I have already initialized the object, which means is the instance already there? If it is, again, don't worry about the static, private, all this we will discuss in future. But if it is already there, then just simply return that. If it is not there, then make a new one. Why this is helpful? This is helpful because now anyone in the, anyone outside this specific class, or I should say anyone in the entire world, cannot make a constructor again and again, which means once the constructor is made, that's it. So I'm making the corresponding constructor inside my class itself, which means that anyone outside cannot make the constructor. They will always call this method, which is, get instance. And if they call this get instance, I will either make for the first time. If it is already made, then I will return the same specific object. That is the beauty of using private with my singleton or with my specific class name, or I can say the constructor. So you might ask, Aryan, then what is the use of constructor overall? Then I can always go and make another method and then call that method itself every time. You might just think of that. But see, that's the thing, that the biggest use case of constructor was that you should not call a method. Rather, whenever you are initializing object, just itself directly at that point in time, your values of fields should be defined. Why I am doing it? I want it to be made only once. That is the use case why I have to go about it inside a method I am doing its initialization. Again, please don't go into it. If there are multiple threads which will make it, still it can make two constructors. But yeah, we'll go on to it when we'll discuss about singleton design pattern. But here in this case, the primary use case of private constructor is that I will be able to make only one instance of that object, which means if I make S1 and S2, both are referring to the same instance, or I should say same object. And that's the best use case of private constructor. Now, lastly, make sure that you remember these key points. First is that a class can have multiple constructors and it can be done by overloading. We'll discuss what overloading is, but just as a quick glimpse of what exactly what overloading means, that if I have same name, you can have same number of arguments, but you cannot have same type and number at the same time. So considering I already have a string s, which means one argument of type string, I cannot have same thing, one argument of type string. This is not possible. So I can either have a int a, that is possible. So you have a same constructor name, you can have multiple constructor, but obviously it should be overloaded. And this is a condition of overloading. And again, if you want, you can increase the number of parameters as well. No worries, if you don't understand this, we will discuss overloading in very detail in the next section. But this is exactly what overloading is. It can be done for methods, for constructors as well. And this is ultimately saying that I can have multiple constructors, which I can achieve via overloading. Now, another thing, that if I am in a specific class and I want to, basically a specific constructor can simply call other constructors by using this keyword. With this keyword, I can call the constructor, I can call other constructors in that same specific class. If you want to call parent class constructor, I will use a super keyword. All this we will see, more used in future LLD problems, all that stuff. So don't worry about it. It's just that you should remember that if you have a specific class you want to call your parent's constructor, just use super keyword. My own constructor, just use this keyword. And this is how you can go about it. Now, another thing, as I mentioned, that copy constructor should be used very carefully, and I should avoid doing a shallow copy, but I should make sure that I'm doing a deep copy. And again, if you just think of shallow copies is, copying a couple of things but keeping the object same. Oh, I should do a deep copy, which means go on to the other object and copy its individual attributes to the new object which you are making. That is a deep copy. That everything is being copied fresh in the very deep and no object is being referenced. Again, let's say if this object, let's say other object, has other objects as well, like it has multiple other objects. If it has multiple other attributes, so I should copy literally each and every attribute. That is what a deep copy means. Literally copy everything else. And this is what you have to make sure that while you are doing a copy constructor. Cool. And again, now we'll come on to some of the interview questions, which are very important and you should know for your upcoming interviews regarding the constructor. First, can the constructor be final, static, and abstract? Obviously, the constructor can be private, which we saw. And why it will be needed? We saw that just so that a constructor or any object can be initialized only once. Can it be final? If you know what a final is. Now, final is used so that anything cannot be overridden in a subclass. And as we know that a constructor cannot be inherited. So if it cannot be inherited, which means in a subclass, it will not be there for my parent. So there is no point of even having it final. That is the reason final is no, not there. Can it be static? Now, static is something which can be called by the class directly. Just saying, okay, this thing, whatever the thing is, can be called by a class directly, the class name directly. But constructor is actually an attribute of an object. Like it doesn't belong to the class itself. That is the reason there is no point of having it static as well. Because you make constructor while you are initializing things. Now you might ask Aryan, but if I go back, this is singleton and I am calling this. So what is happening? See, this is the method. This is a method. Your get instance is a method. And this is being static because you have to call from the class. From the class, I will call this method, which is get instance. And that's how I'm able to get my specific object. But constructor, okay, obviously it's not an attribute of a class. So I can simply say that constructor belongs to an object. So obviously I will not have it static. Lastly, can it be abstract? Again, abstract says that I will not need to define things right now. I maybe the child can actually handle it in future. That means abstract. Again, no worries if you don't know all this stuff. We'll discuss this later on as well. But yeah, just I'm discussing the interview questions right now for constructors so that you don't miss the constructor and interview questions. Now coming on, do I need to have it abstract? You will see not really. Why? Because the constructor must be concrete because it initializes an object. There is nothing called as future my child will implement it. And again, my child cannot even inherit myself. He will make his own. So obviously there is no point of even having it abstract as well. Cool. Next question which can come up is that can like if you define any if you remember like you can have any constructor which you define, then if you remember there was a default constructor, right? If you remember for this example there would have been a default constructor. So the question is that if I ask for new and I give a simple new example, it is trying to call a default constructor. Again, it can have some values, it can be customized, but technically I have not written it right now here. So by default, it will put up some default values. But this is internally, it would have happened. But the moment you have initialized any constructor by yourself, again, I'm saying any constructor by yourself, then this default constructor will not be there. So this will not be present and thus you will get a compilation error. So make sure that you know that if you have any constructor, then you will have to define manually your default constructor as well if you plan to call it. Cool. Next question. That if we create an object of a subclass, what constructor will be called? Which means that if I have, let's say, Aryan father again, why I keep father? Because I wanted to show the subclass. So Aryan father is a class. There's another subclass, let's say Aryan, which will extend Aryan father. So this is a subclass. Aryan is a subclass of Aryan's father. Now, if I have this constructor and if someone is calling this constructor itself, new Aryan, then obviously I will firstly go and call my parents constructor. And this is exactly what will happen, that the parents constructor is called first and then my subclass constructor is called. So even if I'm calling my new Aryan, whatever implementation I have, whatever print statement I have, it will not be executed first. Firstly, I will go here, I will implement or I will write this statement, and then I will come back, then I will write this statement. So if I have A, B, C, D, E, F here, then firstly A, B, C will be written and then D, E, F. So firstly, parent is called and then my child. Okay, next question is that what if you have synchronized keyword in your constructor? Now, for the folks who have watched the course and they are coming back again, then you will see that in Singleton we have discussed about synchronization and all, right? Even if for the folks who haven't watched it yet, and again we are going in the stepwise manner, no worries, you will come on to it later on as well. But synchronization helps us. Okay, multiple threads are not able to access this at the same time. Although synchronized constructor, you can have it, but technically it doesn't make sense because synchronization will help. Oh, things should not be initialized at the same time, or multiple threads should not be able to do that at the same time. But that is an object level synchronization which you are trying to do, and it will be achievable when the object is created. But object is created by constructor itself, so it doesn't even make sense to have an object level synchronization before the object is even created. And that is the reason, even if we have it, it doesn't make sense because it will not do anything. It cannot do literally anything. That is the reason why, what will happen when we use a synchronized keyword with the help or along with any constructor. Now, the biggest thing which you have already seen, that can a constructor be inherited? No, because any subclass can call its corresponding superclass with the help of super, and constructor are for a specific class only. This we already saw when we were discussing about final, starting, and abstracting, right? Okay, continuing. That can a constructor have return statement? Obviously not. This is what we saw in the very beginning, because constructor is used to set some fields or set some attributes of a specific class and not to return anything. Now, there is a catch, that they can have a return statement, but it is to exit early. It is not to return a value. What I mean by that? So again, that's a very good interview question. That can a constructor have a return statement? Answer is yes, but not a value. So you will see that you have a return statement. This is just so that, okay, whatever condition I have, I will exit it right now, then and there. I will not reach here at this point. Why it is useful? It is useful, let's say, if I have some example, I make an object, I set the value is 10. Then when I call the display function, it will check and say the value is 10. But let's say I call with the value -5. Now -5, let's say for me is a invalid value, and I don't want this value, this object 2 having a value of -5. I don't want that. I want key, okay, even if I have some value which is negative, okay, I will put a default value, let's say 0. But I don't want this value to -5. So what I will do, I'll simply say, bro, check if the value is less than 0, then just make sure that you print some condition, some error log or something of that sort, and return right then and there. Thus, value is never even initialized. It always remained its default value, which is 0. And that's the reason if we print it, you will see it will be the value of 0. And again, it came here in this specific thing and printed out this invalid statement. And that's what you did. Now, ultimately, as a last point before we go on next section, constructor ultimately is to initialize object in our oops, and we know the importance of oops as per last section. Now, I hope you guys liked it. Let's go on to the next section. Okay, so in the last lecture, we saw about this keyword, right? Now let's go a bit deep dive into this. Primarily, the use case for this keyword is referencing the current object. Now, how to do it or why it is important? Because it helps us to remove that ambiguity. It helps us in chaining, passing by reference, and also time reminding what it is. Let's see now. So basically, this keyword or this how it works in Java, it's by referring the instance object. What it means? It means that, for example, I'm having anything. I'm having a constructor, I'm having a method, or anything of that sort. I have this instance variable, I have this parameter variable. Technically, this name belongs to my specific object, this thing. And this name is what I'm passing as a parameter. So there's an ambiguity here that what name is what name. So when I say this dot name, it is referring to the current object's name, and here it refers to the name which is passed as a parameter. So it helps us to resolve that ambiguity. What is ambiguity? Differentiating between the instance variable or any method or constructor parameter which we have. This is that parameter. Now, is it the only thing? No, obviously not. The thing which we learn in constructor is constructor chaining. How that works. If you have a simple constructor, right? Simple constructor having one argument, you can call another constructor. Here this will refer same, same objects constructor which I can call, but with a different argument. Here I have name and 0. Now, how will we figure out Rn which constructor will be called? Obviously, there will be only one constructor following this parameter definition, and that is what is called directly. So name and 0 is being passed to this specific constructor, and that's how I will be able to initialize, or I should say call another constructor. This is what we saw in the last section. Now, is it the only thing? Obviously not. I can return the current object as well with the help of this keyword. Now you might say, Aaron, what is the use of it? I am returning the current object. As you can see, person, we have a person class, but I'm returning the current object with the help of this keyword. Now, you might say, Aaron, it seems confusing. Also, what's the use of it? See, the use of it, although you will learn very deeply in builder design pattern, but you can also see it helps us in method chaining. What is that? If you see that I have p dot set name Bob, I have set name, and then I set the name to the Bob. It returned the object itself, which is if I want to call the display method, right? I can call this, see, this display method is one of the behavioral methods of the person class. But if I have a person object P, then I can easily call a display method. But now I'm saying I want to chain it up. I want that, okay, I want to call display method again without even calling, let's say, another P dot doing something. So this is how chaining worked. Firstly, call one method, then you call another method. This is very, very, very important in builder design pattern, which we will see later on sections and lectures. But this is how exactly your method chaining would work, and I can primarily use this keyword to return the current object. This is what it is happening right here. Cool. Now, the next thing is, what else can we do? Obviously, we can pass that current object anywhere we want. How? Obviously, if we have another function, that function, I am accepting an object. I can pass the current object itself into another. It can be a constructor, it can be anything, right? Primarily, it will be a method where you are passing in the current object. What this will help me? This will help me, let's say, if I want to write a method, that method is introduce. This doesn't have any arguments, but I'm calling it from an object. So P is a person object. I'm calling this introduce from this specific P. Now I came here. I want to apply something on this P. But when I came into this specific thing, right? Because it's of a class, right? This thing is of a class. So if I came inside an introduce function, I want to know who called me. So in this case, P called you. If P called you, then obviously I can access who called me by using this. And this is how I can use this keyword just to say, okay, this person object has called me, and I can just, print anything whatsoever I want. This is how you can easily know who called you and work on that thing. When I say who, I mean that which object called you and you can work on that thing. Now, obviously, you saw a lot of advantages. Just for a summary, I can give it helps us in readability and maintainability. It helps us in method chaining, which is very important, and also passing the object by reference. What are the disadvantages? Doesn't it seem like it is, doesn't seem like that it will have some disadvantages, right? The biggest one is that it cannot be used in static methods, or whenever I'm referring a static context. Why? Because static, it belongs to a class, which means that it is not for any specific instance. This is for a class, which means I will access by saying example dot display message. This is how I will access it because it is specific to a class. But inside a thing which is specific to a class, you are asking the thing which is specific to an object. That doesn't make sense. That is kind of conflicting behavior. That is the reason it is not possible. So whenever you are trying to call example.display method, it will give you a compilation error because it is not even possible. It is kind of conflicting at all. Right. Now, other thing is obviously, as many of you might have felt, or not now, but maybe previously, is the clarity. People literally get confused with this keyword, and it is not because of you being confused, it is actually very confusing as well. Because see, whenever something is written this, then how this is calling, who is calling, where it is calling, all that you will figure out by yourself. And that is the reason it makes it a bit confusing. Same way, if you will in future, you will learn about method reference. This is also very confusing. Although it is clean, although it is modular, although it helps us to call the method at runtime, but still it is confusing. That's the same thing with this thing, with this keyword. It makes things confusing, very, very, very confusing. Now, lastly, as I mentioned, it is flexible and adaptable to varied situations which we have, making the code reusable and also making it more clean and modular as we saw previously. Ultimately, as a summary, it helps us in resolving conflicts as we saw name, this dot name and name. It helps us to support chaining, calling multiple methods and also passing thing by reference where I'm calling this so that I can call another object by saying, okay, I'm passing the current object. Cool. I hope you guys got it. Again, these all things are asked in interviews a lot. So please make sure that you watch it very carefully. Again, anything if you think that was not understood, no worries. Everything will be covered in the next section. Now we're going to start with one of the most important pillar of OOPS, which is polymorphism. As the word itself says, poly which means multiple, morphism which means forms. It is nothing but multiple forms. Now, what I mean by that is same operation can behave in different forms in different scenarios. Why it is useful? It helps us in code flexibility and reusability. How? Simple. If you have anything, let's say you have Aryan. Now Aryan has, let's say, a method. Now, based on kid, it will perform differently. Based on wife, it will perform differently. Based on job, it will perform differently. Same method, based on the argument what I am getting, will perform differently. That is nothing but is your polymorphism. Now, the biggest thing, also one of the interview questions, is what are types of polymorphism? Again, there are two, which is compile time polymorphism and one is runtime polymorphism. So, firstly, compile time polymorphism, which also called as method overloading. Now, what it mean? Overloading. Method overloading. Now again, whenever I say method, you can always assume operator as well. Because again, any operator is nothing but a method as well. Cool. Now, what it means? It means that the method will be overloaded. Overloaded as in another method will come in with some different arguments or with some different number of arguments. What I mean by different number? Overloading can be achieved with different type or different number. I'll show by example as well, but this is how exactly it will happen. Now, why it is required? It is required for your method resolution. What is resolution? Resolution as in, if I give you a method, let's say this was the method, RIN method, it it needs to be identified uniquely via its type. Okay, first is kid, second is wife, third is job, or via number. Okay, kid, let's say two kids, kid one, kid two, or maybe let's three kids, or maybe two wives. Okay, not a good example. Yeah, two jobs, not a good example. Okay, so this is how you can go about it. Now, example will be very simple. For example, I have a start method. Same way, start method. I overload this method, which means in the same class vehicle, I have two start methods with the same name, same return type, but the argument number are different. As you can see here, I have one argument, just string. Here I have string and speed. So why and how to remember? But the biggest thing is people get confused between overloading and overriding. Overloading. Just imagine by the help of truck. In a truck, you overload, which means that you keep on putting same things again and again. So you are putting the same thing again and again. Start method again and again. You're putting in. You're overloading this vehicle class with this start method. But obviously, to uniquely identify that this is a start method different, this one is different, you have to change the number of arguments or the type of argument. Which means I can also have a start method with just one argument having that as integer. It should be something different than string. So this is your method overloading. And as you can see, a simple class diagram would look like that I have a vehicle class and that will have two methods, both with the same name, just that the number of arguments are different in this case. Now, as I mentioned here, the number of arguments are different. We can also change the type of argument, because if I have string, I can keep integer as well. And that is the type being changed. With that also I can achieve same method overloading. Again, I can have a combination as well. I can have a combination of type and number, which will ultimately be nothing but your number itself. Or maybe we share. Okay, if the argument number are two, but one of them has string, another has string integer. So that also is possible. It's just that two functions should be uniquely identifiable. Cool. Now let's see what we can go. What is the key feature of this? Obviously, the method is resolved at the compile time, because obviously you have two same names. So your compiler should be able to uniquely identify, okay, both are different. And thus, what it helps us is in a better readability and cleaner code. Why cleaner code and why better readability? Because the same name is being used for the same operation. If let's say you're not fortunate enough, and let's say you have to use a different name, then you might end up having a start underscore vehicle type, start underscore vehicle id, which will give you an untidy code, giving different names unnecessary, having to keep or having to make the name different. That's what your that like that This is actually what can make your code untidy and unclean, but it helps us in better readability and also cleaner code. Now, as we saw, we have another one. First one we saw as compile time polymorphism. Now we have runtime polymorphism, also called as method overriding. Simple. Override something. Whatever you have previously, just override with a new value. Now, the catch here is it's a dynamic, which means at runtime, this is actually identified that which method I need to call. What it means? It means that it allows a subclass to provide specific implementation for a method already defined in its parent class. What they are trying to say here is that if I have a car as a subclass of vehicle, although vehicle has its own implementation of start method, still when a car class overrides this start method, then whenever in future I am making an object of car, no matter I am calling vehicle start, right? I am calling vehicle. See, this my vehicle is actually vehicle, and I am calling vehicles start, which means technically I am calling this vehicle start. But because this object is of car, which means that I'm technically calling this start, and this is being overridden from the parent. So imagine that this is gone and overridden with this new value, and that's what is actually called as runtime polymorphism. Because at runtime, when this program will run, at that point itself I will be able to see this method, see this output itself, or see the actual value coming in. And that is how at runtime it figures out, okay, this is not the actual stuff. I should go on to a child and call his method. And that's how it will be this line which is printed starting a car when I will call this. So obviously, the biggest thing or the biggest feature for runtime polymorphism is that the method resolution happens at runtime, and that is also based on the actual object type. Whatever object I am calling, if it's a bike, car, or a truck, on that basis, on runtime, it will decide which start method to call, because there can be a possibility that this is overridden. If not, then obviously, let's say if I plan not to override it, I can do that. I can do that simply, which means I will ultimately, whenever, if even if I am calling, I'm making a cars object, still I will be calling my vehicles start method. So it is dependent. If my code has overridden it, then on runtime it will check it and then will give the correct output for me. Cool. Now, another one of the important feature is that this entire thing will be resolved at runtime, and again, JVM does that task to determine, okay, what should be the appropriate method implementation. As I showed that, okay, you need to figure out if it's a parent's implementation or the child implementation which I have to call. Now, advantages you saw literally just now, that I can reuse that code, and I can write the same variable name and reusable code. And obviously, as you can see that, okay, if I have a simple interface as well, although we saw about classes which we are overriding those methods, but simply interface, if even if the classes implements those interfaces, still they will have to override it. Obviously, here in this case, it is fixed what is being implemented, but still this gives us that clean code and gives that reusability. Okay, I can reuse that specific function, and that's functionality wise I am good. Again, next thing can be flexibility, but before it, you will also see that this thing will come again and again, that because we are using a vehicle interface, although it can be a class as well, but the catch is, or the best benefit is, that I was able to only call vehicle.start. I don't have to specifically call car.start, bike.start, and all that, and so on and so forth. So, what I can do, if I have these methods, I can put them in a list of vehicle. And then let's say I call them as vehicles, and I'll put in this list. I'll put this my vehicle, this one, and this one. Again, I'll name it differently. It is, let's say, 1, 2, or 3. I'll name it differently. I'll just put it there, and then I can simply call start method, right? And with that I will be able to simply, as you can see, I simply iterated on all of this start method. So that's how the reusability happens, because elsewise, if I would have not used it, I would have written, okay, bike of, bike equals to, let's say, new bike, and then same way for car, and then same way for truck. So I have to write bike.start, car.start, truck.start, which is kind of unnecessary. I can just write simple vehicle.start, and that's how I can use it. Cool. What is the next thing? Next thing is flexibility. Obviously, that's the dynamic behavior. What I mean by that is that obviously you can have same thing. It's just that it's a bit flexible now, that you can simply call vehicle start and dynamically attach anything, either a car or a bike or a truck. On runtime as well, you can attach literally anything and then call the corresponding start method, and based on what you attached, it will call that corresponding start method. Again, the same thing, that I can literally attach anything, car, bike, or truck. Next best thing is extensibility. As we saw, that adding any new class, because see, this entire LLD is any design which you are writing should be extensible. When I say design, I mean obviously code design, that should be extensible, which means that even if in future bug comes up, obviously I can have the same method, implement that, and this will override the existing method. Obviously it's implementing, so we don't have any existing implementation, but even if it's a class, then also I can override with the new method implementation. And again, the same piece of code will work now. I don't have to specifically go and call or make bus instance and then call do a bus.start. No, I can just simply put that bus inside my vehicle and then call vehicle.start. Same piece of code is being used, making it more reusable and extensible. Now, you might say, Aaron, things look so good. Like, there are no disadvantages as such, right? Yes, technically, they are literally not. Literally, there are no physical disadvantages. They are not. So what is this? It is simply, unnecessary ones which I can simply make just for the sake of just telling, okay, these are the disadvantages. What are they? Obviously, the complexity increases, but again, this is the entire essence of LLD. For LLD, making the code complex technically simplifies it in long term, but it might seem complex for anyone seeing multiple classes extending something other. So basically it's kind of dependency being built and then resolving that dependency just to understand the corresponding code. That's the entire essence of one of its disadvantages. Another one can be a bit of a very, very, very less performance overhead because the JVM has to resolve these methods at runtime. So JVM will try, oh, what is this? Then go and call it again. But this difference is very less. It will be there, they will be overhead, but always very less. Ultimately, last the conclusion points, I can simply say that polymorphism is very, 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 very highly used in OOPS, like literally. As we saw, there's compile time, there is a runtime. It is method overloading, this is method overriding. What ultimately helps us is giving a cleaner, maintainable, scalable, and reusable code. Cool. Let's go next section and let's learn another pillar of OOPS. So now we are at a next pillar of OOPS, which is inheritance. Now this is very, very, very important. Literally in the entire LLD, you will be dealing with inheritance itself. Like this is that important. Now, basically inheritance is inheriting some properties and methods from my parent class, which is extending or overriding its corresponding functionalities of the parent class to the corresponding child class. Why this help? It helps in code reuse, redundancy, improving maintenance, having multiple good stuff. Everything good which you can think of, inheritance will give you. And also, if you remember something in the last lecture, we are discussing about inheritance itself, which is obviously it supports polymorphism as well. Again, we will see about runtime polymorphism, entire overriding, all that stuff, where again inheritance will come in picture. Now, very, very, very important is that types of inheritance, not in terms of interview, because no one will ask for the type of inheritance, but people will ask something inside it, which we will see later on. So first one is single inheritance. It simply says that basically there's one class which will inherit from one parent class. So as you can see on the right side, I have one animal class. I have one animal class. And there is one dog class. There's one dog class. Dog extends animal. That's it. One parent, one child. That's your simple single inheritance. Next one, as we say, multi-level. And what is this multi-level? Obviously, as you can see, multiple level will be there. At each level, one person will be extending someone else, or basically inheriting someone else. So ultimately, there is a class which will inherit from a parent class, and that specific parent class inherit from another class. That will keep on going. So I have an animal, then I have a mammal. It extends animal, then I have a dog. It extends a mammal. That's how a simple chain is going up. This is called as your multi-level, multi-level inheritance. What's the next one? Next one is your hierarchical inheritance. Hierarchical, as the word itself says, you must know about a family tree. So your family, two people are there, then you are born. Oh, no, not really. One person can have multiple children, then another person can have multiple children. But Aryan, two people are there, one is born. That is also correct, right? Yes, that is correct. But if you look at a family tree, usually there are two people, then they have their own families, they have their own families, then they have their own, and so on and so forth. But yeah, obviously, two people can give birth to one person. That itself we can show as a family tree. Yes, maybe we can. But yeah, the entire essence is that you take help from one person, and then hierarchically, dog also can extend because dog is also an animal, cat is also an animal. So basically, you can extend both of them. Now, what's the benefit of this? Obviously, multiple subclasses can inherit from a single parent class. For example, if I have a eat method, I don't have to implement that eat method in my dog and cat. I can simply reuse that eat method in both of them because obviously both the animals will eat. Now, as we say that it will benefit by sharing the common properties, common behavioral properties. Now, we saw we saw multi-level inheritance. What is multiple inheritance? This is exactly what we were trying to go towards when we were saying, oh, if two people and I kind of take, you know, the properties of both of them, that is something nothing but multiple inheritance, and that is not supported. Why? Because it generates a diamond problem. What is that? A diamond problem is nothing but it creates ambiguity when there is one class which inherits or which extends two classes. How? Let's see. If I have one class, let's say hybrid animal, it extends dog and cat. Now, both are classes. Dog is a class, cat is a class. It has this method. Now, when hybrid is there, obviously it's a class, it is extending these two class. It doesn't need to implement any method. It doesn't need to implement the sound method. No, it doesn't need to do that. It can simply call the sound method from my hybrid animal. But the question is, which sound method will be called? Will it be a dog or will it be a cat? That's the question. And that is the reason, because of this ambiguity, I or in Java, it doesn't support that multiple inheritance. But Aryan, what if I want to do this? Obviously, you can. How to go about this? We can achieve that by multiple inheritance. You can achieve that by multiple interfaces. What is that? So rather than classes, which will have the concrete implementation of sound method, I will rather take as, you know, inheritance, or I can say, okay, it's an abstract method. What will help? It will say that if a hybrid method will it's simply implementing these dog and cat interfaces, then it has to implement its own sound method. And with that, because there's no ambiguity, he will have to implement. He doesn't have to choose from any of the parent. That's the reason it is possible. So you can simply implement your own logic of the sound, even if you are, implementing your having interfaces of dog and cat, and you're implementing those interfaces. Cool. Now, the biggest thing is, can we mix it? Yes, we can. And that's the beauty that we saw. We have interfaces. We saw that we have classes which we are extending up. We can mix both of them, which means we can have a hybrid as well. Classes as well as interfaces can be mixed. How? Simple. If I have classes and I have interfaces, as we saw previously, we can have multiple inheritance, but we can implement multiple interfaces, but we can only extend one class, and that is because we have that diamond problem which can come up. So it is the reason you see that I have an animal class and then mammal and pet as an interface. So my dog can extend one class and implement as many number of interfaces as it wants. And you can see that it override these methods. But again, this is okay because it only extends one class. That's it. And that's the primary use case. But again, it is good as if we might want to implement multiple such classes. Now, the catch is, Aryan, which one should I use? Maybe should I use, extend a class, or should I implement an interface? That we will see in the next section when we will be going up to abstraction and all that stuff. But right now, the entire essence is what you're learning is inheritance. You're inheriting some of the classes. Obviously, advantages you had been seeing so far, the everything good you can think of that is achievable with the help of your inheritance, which is code reusability. What I mean by that? Obviously, you have that eat method. You don't have to implement in any of your subclasses. Even if how many classes you have, you don't have to implement it. This exact same piece of code can be reused. Next, ease of maintenance. Because you can reuse the piece of code, thus you only have to maintain this piece and not anywhere else. So any kind of issues come up or any kind of maintenance needed, it is needed only at this piece of segment. Next thing, extensibility. Obviously, you can add anything else in future. Let's say right now I have dog, I have cat, I can add bat. Not only this, but also again, if and only if needed, I can simply override that method. For example, I don't think, okay, the bat can eat. Let's say bat can only drink. So I'll just simply, maybe I can just override that method by say, okay, don't eat. Just simply, I'll say, okay, runtime exception. It will not eat. So that is the freedom. I can just extend the same thing for anything whatsoever in future. And if I think that it doesn't make sense, okay, I can maybe remove it from here, or I can simply implement that by saying, okay, don't do this in this method. Now, next thing. Next thing is, as we discussed in the last section, it supports polymorphism, which is method overloading. What is that? As you can see, and this is the entire essence of inheritance, that I have dog, I have cat, it can simply extend my animal. And with that, I can have that sound method as well. Again, not necessarily I have to implement it, but obviously dog will have a different behavior of sound. That's the reason I have written, or I have overridden that specific method. And here also cat meows. So that's a sound method being overridden. So everything is so good in it. Are there any disadvantages? Technically not, because again these things are so good that they don't even have any disadvantages. But still, just to write it down, we can say, okay, it actually has this increased coupling. Now, although it is required, very much required, for to stop the corresponding code duplication, but still you will see that as I mentioned previously, if you have some method and one of your child doesn't implement that method, then you might end up removing that method. But if you remove that specific method, there is a possibility that any of your child who hasn't implemented it will start breaking. That is the reason there's a very tight coupling, that you cannot change your parent. No, this cannot be changed. You should always make sure that children's are being changed. And again, these things we will see in as we go on more towards the design patterns and design principles. But yeah, that's the one thing, that you will have a bit of tight coupling. But again, this is very much required to stop the corresponding code duplication as well. One another very not important thing is complexity. Obviously, because of this entire inheritance in picture, your code becomes complex. But yeah, the entire essence is that the entire LLD is very complex. So you will see a complex piece of bit, but again, LLD itself is nothing but making sure that you use a piece of code and you reuse it, you maintain it such that it is extensible and scalable. Doesn't necessarily mean that it cannot be complex. It can be complex at times, because again, you can have multiple deep nested in inheritance structure, which obviously can be at times difficult and can be super nested, that you will be literally in deep trouble. Lastly, as a conclusion, obviously you should know about single, multi-level, hierarchical, and hybrid inheritance. Again, with multiple inheritance as well, you should know about time problem. And the best essence for this is, it helps us in robust maintainable code, or I should ultimately say that every good word you can think of: robust, clear, scalable, maintainable, every good word you can think of, your inheritance help you able to achieve it. Cool. Now this one, we saw another pillar of your oops. In the next video we will see next pillar, which is encapsulation. Third pillar of oops is encapsulation. As the word itself says, encapsulation. Encapsulate something. You see that capsule that has something inside it? You don't know what inside is the material. It's just that you are given this thing and you have to use this thing only. Everything, very complex stuff inside it is just hidden from you. Again, it can be a mixture of multiple things, but that is simply hidden. What it means, it restricts that direct access to those like it can be chemical, it can be some formula. The direct access to it is not given to you. You are just given something around it, and that is what you can access, that is what you can touch. Although again, you can argue with me, Aryan, I can open it and then do it. Not that is what I'm referring, but obviously in this case also, for the folks who know, there's a method or there's a strategy called as reflection, with which you can access something which is private. But still, the entire essence is, faithfully, calmly, what I can access, I just restrict that direct access, so that naive person should not be able to access things directly. And again, that too for some certain components, so that I can ensure controlness. What I mean, and how will I do it? I will do it via private. What is this private? As we saw earlier also, private helps us at anything outside the class. which again, if I define anything inside the class which is private, anything outside the class cannot call this private thing. It can be a method, it can be an attribute name, anything. So if I want to modify this, then I will use some getters and setters. I'll make them public so that anyone can actually access those getters and setters. Now you might ask, Aryan, then if you will have some getters, okay, it's simply getting it. But if you will have some setters, then isn't it gonna modify it? Yes, but I will have that controlled modification, which means that I, as a mediator, will make sure that whatever is there, I will handle it. How you will modify it, I will handle it. Everything I will handle. How you will access anything inside this specific capsule, I will handle that. Now, let's see what are the key features of encapsulation which we have seen. First, and very important feature is data hiding, as we have been seeing. How we will do that? We will do that via using private. Again, there are multiple level of access modifiers which we can have and which we will see it later on. But the primary, and you will use mostly, you will use as a private method via which you can hide the data. What it will do? It will simply prevent the direct access to sensitive data. See, make sure data any data whatever you have is sensitive no matter what. Data itself, the word data itself should always be linked with sensitiveness. That is it. And it can be done, data hiding can be done, which will prevent the direct access, which means I will still be able to access it but not directly, which means I will have a controlled way to access things. Next thing is modularity, which means I will have a data and the behavioral, the behavior, how I will access it, how I will set it, get it, will be separate. So I will make things modular. Next thing is security. Very, 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 very important. And that's the primary. That's the primary thing for encapsulation. Security, which means protect the integrity of the data. No one can see it or modify it without you knowing it or without you wanting that to be modified. Next is flexibility. That gives that, okay, you can have these setters which can help you to modify things if you want. If you don't want, you can not let the others modify, which means that inside this method, which is a setter method, you can change its implementation to any which ways so that it is flexible for anyone for it to modify or not. Now, how to do it? Obviously, I will have some access modifiers. Here I have private. Again, right now in this lecture, I will show you or showcase you with the help of private and public. But in the next future sessions, we will see about actual access modifiers, default, protected, and all that, and where to use when. But still, the essence of encapsulation is this thing cannot be seen or modified by anyone else. To see it, I will have to use a getters. To modify it, I will have to use a setters. Now, you will see that this deposit can be accessed, can be set with a specific amount, but how it will be set is handled, is controlled by me. Withdraw can be done, but how it is handled, it is controlled by me. No one can come and change their amount directly. No, balance cannot be changed. It will be changed via these methods only. So I am controlling how anyone accesses it. So people will deposit or withdraw some balance. I internally will make sure that how I will modify it. So what happened here? Obviously, I use private variables just so that I can restrict the access. I use public methods for getters, for controlled access, setters for valid updates. I want the updates to happen only and only as what I want it to be. The biggest thing which happened above is data integrity. Only the data and how I want it to be modified, only in that way it was modified. And technically these are its advantages itself. But still, if I just want to say it again, obviously there's data security. Again, this is what we saw earlier as well, that everything is secure. I am kind of going and letting others do as what I want. And the biggest thing, the sensitive information is not exposed to anyone. I am controlling it, what needs or what can actually go away. Biggest thing is ease of maintenance, which means that this method, it can be modified and implemented as and what I need. I want to change it, I want to maintain it, I can just maintain the specific method. It's very simple and straightforward. Same way for flexibility as well. I can simply change this method to the way I want things to come. Let's say if some fees is coming up in future, I can simply integrate that fees. Simple. Although this is not a good implementation of it in terms of simple low-level design, but in future we will see about strategy design pattern which will actually help us to integrate fees. But right now, imagine that you are controlling or have that controlled behavior, whatever needs to be done, and also flexible enough that in future the balance amount is changed based on certain factors. Now, next thing, obviously, it has that best case of readability, because now the balance is being changed with the help of certain methods. So anyone who is coming up can simply read up this deposit or withdraw method and can understand what exactly will happen. Now, is there any disadvantages? Technically not, because as I mentioned, these oops are literally the gods of LLD. But still, as we saw, that there is a slight overhead. But again, as I mentioned, that overhead is much better than being risky, which means having protection is much, obviously it's an overhead to have that protection and all that stuff, but it is very, very, very useful and safe. Just because of that safety thing, I should always be at this overhead. That writing all these getters, setters, all that stuff, that's unnecessary, and that takes time. But still, it is important so that you are only letting things which you want others to see. Next thing, complexity. Always see, entire LLD itself is complex. So I told this previously as well that entire LLD is complex. So you will have that complexity stuff. Lastly, as I mentioned, just to conclude it, you with help of encapsulation will have controlled access to data. Again, the best part is it will help you maintain data integrity, create that flexible and robust applications. Biggest part is data integrity in this. Cool. Now let's see in the next video the fourth and the last pillar of our OOPS. Okay, let's go on to the last pillar of OOPS, which is abstraction. Again, in this, we're going to see a lot of interview questions, like literally a lot of interview questions, because this is a very, very important topic. Now, this thing, this abstraction, as the word itself says, it primarily focuses on exposing only the essential details while actually hiding the actual implementation from you. Now, what it means, for example, you have a car. Now you interact with accelerator, brake, and steering wheel, but you don't know on behind how engine is working. Same way in Java, abstraction, abstract out this thing and only giving you this thing. About how it works, you don't know. So abstraction in Java is achieved via using abstract class and interfaces. Now we'll start off with abstract class, then we go on to interfaces. But before we do that, the primary issue, if abstraction is not there, let's see. So if the abstraction would not have been there, then I would have wrote dog class, make sound, sleep. Same way cat class, make sound, sleep. Now you will see that okay, both are sleeping. Okay, both are sleeping. We saw it's kind of violation of the dry principle. Now, what is this dry principle? It is simply don't repeat yourself. We will see it later on in the section of our LLD series. But again, without abstraction, this is the case. But if I plan to use abstraction, then I can remove this specific redundancy. How can abstraction help me? Is by removing that specific repeating code, which means I will remove, I know that sleep method is same, so I will technically remove that piece of code and ultimately get it. Now, the thing is that, okay, what abstraction helps us to achieve is giving a common structure. Why it is important? Structure is very important for very highly complex codes. Again, even if any which ways, for example, this LLD course, it is structured. Structure helps you to achieve your target easily and fluently. That is the reason. Structure is defined or can be given via abstraction. Flexibility, right? If you remember in the previous section, we saw inheritance. So we saw that, okay, we can run a for loop of animals, and then we can just, we were running a for loop of vehicles, and then vehicle, we were accessing some of the methods for it. Same way, if I could abstract as an animal, then I can refer dog and cat both as an animal rather than referring them as dog or cat. Now, Other thing is that I will get rid of that tight coupling. What do we mean by that tight coupling? Tight coupling is that I would not, let's say if I have to pass an animal. Now I know, okay, it can be either a dog or a cat, but let's say if I have to pass this, so I will have to write either dog, dog, or maybe I have to write cat, then cat. But if I just write animal, then I can pass either dog or a cat. I don't have to define it. I don't have to tightly couple it either with a dog or a cat. It can be literally anything. It can be in future anything else as well. It can be literally bat. Again, I'm not sure bat is animal or not, but yeah, it can be anything in future. So this is exactly how I can get rid of that tight coupling. So if you look at it, how abstraction helps us, it helps us by simply saying just define what of an object and hide how of an object, which means I will define a common structure, but which ultimately means that behavior that must have, while we leave specific implementation to the subclass to implement. Now, because of this, as we already saw, that it will help us to reduce that code redundancy, and also I will have some shared centralized logic which will actually help us to have more scalability, more readability, less duplicate code, and more flexibility. So ultimately, as just some few jargons, I will be able to achieve scalable code. I will have consistency because I will be using same set of code in different subclasses, and also I will facilitate polymorphism. If you don't know, just we saw this in the previous section itself. So ultimately, abstract class is the one which can help us achieve abstraction. How? Basically, abstract class act as a blueprint of any another class, which means that it gives us a shared behavior 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 yeah, it gives us a shared behavior. What it means, okay, I can have a method and that method has some specific implementation to it, and thus I can use that shared implementation to any of my subclasses. Now again, the best part about abstract classes, I can have abstract methods as well as concrete methods. We will see all that, but this is the best part, the beauty. Although we will discuss in very deep about concrete methods, abstract class interfaces, all that stuff. But the entire essence or the best part about abstract classes that I can have both abstract methods as well as concrete implementation. Now again, what it helps us by giving a common structure and also giving the flexibility that I can either define this or ask my children to define it. And ultimately, the biggest thing is because this is not a concrete implementation, right? Abstract class is not concrete. So obviously, in this case, we have to make sure that the abstract class should not be instantiated. And that's ultimately what we will also do. Now, as we were seeing so far, that what abstract class is and how it achieves all this, all that stuff, just have a quick look of how this abstract class is defined. It is simply defined by giving an abstract keyword. And as we saw, that abstract class can have abstract methods or it can have concrete methods as well. I can have both abstract methods and concrete methods as well. But obviously, if I have some abstract method, the child will have to override it no matter what. If the child will not override it, it has, if the child will not override it, it will have to be either abstract or, yeah, that's the only thing. It has to be abstract if it will not override it. Now, the thing is that what are the good points of abstraction? As in, that's good that okay, we have abstraction, but what are the good points? As we saw above, that it will help us in code maintainability. How? I just need to maintain this piece of function in just one class. That's the abstract class. And don't need to pass it downwards. Now you might ask, Aryan, why can't I do the same thing in a simple class? Yes, you can do that. That's a kind of benefit which comes in a normal class itself if we don't repeat things. But yeah, that's the thing which you can do in a normal class itself. But the best part is enhanced flexibility, which means obviously again this is also the same for normal classes as well, that you can have its own implementation and do the corresponding change and just call that specific dog method. Now, reusability, same way, that abstract class will have its own implementation. I can reuse that own implementation. Now, you might see one small catch here that I don't have any specific abstract methods. So is it a good state? Yes, it is. But what's the point of abstract? Okay, the point of abstract means that I will never be able to instantiate an animal. Now, how it is useful? Logically, it is, because logically you will see that you will never find an animal object. You will find either a dog or a cat or a an elephant, anything, but you will find a specific animal. You will not find any animal. Like that is a picture. Animal is a picture, but what exactly is an animal? That is something we have to check or go about it. So that's what the use case of having abstract is, even if we are not having any abstract methods. And again, obviously, the using functionality, it is simple. It's inheriting from animal. Now, the next thing, security. Obviously, as we saw that we don't need to showcase the user about engine. We can just work on acceleration, brake, and all that good stuff. So, which means that, okay, if I have animal, and let's say if it has some secret, and then I have some method, I can just use that specific secret, and I would not want my children to know that specific secret. Again, if I want to show them, I can show them in a controlled behavior. That is exactly what we saw in encapsulation. We can show things in a controlled behavior to anyone outside. Cool. That is the one of the good points about using it. Now, the biggest thing is there any disadvantages for it? Technically not, because you will see that, okay, complexity is something which is obvious, as we have been seeing so far. You will have that complexity, but the most or the biggest challenge here is that overusing abstraction. What is overusing abstraction? Unnecessary use of abstraction is literally a root cause of very complex problems. People unnecessarily use abstraction, which results in confusion, unnecessary code, and also for sure implementation overhead. For example, obviously, you will see that, okay, animal. I unnecessarily define abstract methods, fly, swim, and then the child will have to implement it. Obviously, dog cannot fly. So, what is the point of having it? So, which means that before implementing or before having any abstract methods, you have to kind of pre-plan. It is not okay, like on runtime, I'll just plan this entire thing. It needs an entire architectural design of how you're gonna implement it. And with that, you will have to have those corresponding methods. Again, you can go bottom up as well, which means first you implement things and then you realize, okay, this is common, so you keep it at a common place. But obviously, you have to go top down. Okay, just think, okay, what exactly you need, and then others will implement this, and maybe extend this and all that stuff, and then you go about it. So obviously, what is the issue with this code? Obviously, we have unnecessary, irrelevant methods, for example, fly. And obviously, this is not only unnecessary, not only it is actually dog is overriding it, okay, it is giving some exception, that is completely fine, but it is also causing confusion for anyone who is reading it. How can a dog fly? Even if I just, if I just call this method, and if I make an object for dog and I just do dog dot, if I'm able to see fly, isn't it weird if you are doing a dot and then you are seeing a fly to it as a method? That's the issue. That it causes unnecessary confusion. And obviously, you will have a runtime errors. You have to handle that separately, because obviously you will throw an exception to it. And to handle it, you will have to handle it on your main code. Now, what's the better what's the better way to actually handle this? Because we have been seeing abstract classes, we have been seeing that, okay, we are just having those implementation done. What's the best way to do it? Obviously, we can use interfaces, because what interfaces say, that it says that I can have some specific behaviors. Now, what these behaviors are will be implemented. But how is it different from abstract method? I can have multiple interfaces, which is I can have multiple inheritance, and that is the reason. And that is the reason I can keep this one abstract method in one of the interface and keep this other abstract method in other interface. And with that, I will be able to implement both the interfaces and get my class done. So it helps us to only make relevant interfaces and avoiding the irrelevant methods in any specific interface. How it will look like? I will have an interface flyable, interface swimmable, which will have swim and fly method. Again, they can have their own corresponding other methods, but that's the best part, that I can now implement swimmable if I want the dog to swim, and I can have bird which can actually fly, which can implement this thing. So I will not have to the dog will not have to implement both the things, flyable and swimmable. No, that will not be required, and that's only possible again even if you have multiple other interfaces. Okay, if I have other interface as well, I can put it as comma and then have multiple other as well. But is there anything or any issue with the our abstraction or abstract class other than obvious complexity portion? There's a bit of overhead. Again, as we saw that debugging becomes harder, and if they are overused, they make the program very complex, because unnecessary abstraction for a very simple system is unnecessary, like literally unnecessary. For example, if I just had a dog, again, for sure, if and only if, for sure in future I know that okay, my entire firm depends upon only dog and I only cater for dogs. Even if, well, like, my let's say my brand name is itself dog life, right? I give and only cater for dogs, then what's the point of having animal? Like, it's unnecessary, right? Again, I'm saying only when the business use case says that I only would be needing dogs. So why I am actually having another animal and then implementing a dog? Like, it's kind of unnecessary, right? I would have simply said that go and make a dog. That's it. Because I know in my business use case, I only want a dog. Again, it is more dependent upon business use case. Although to be on safe side, we can just have an interface, and then that interface can actually say, okay, I will have a cat, I will have a dog, and then animal has an interface. That's for safe side. But obviously, if there's a business use case, so don't complicate it. Get to know the business use case first. Now, obviously, why it is better, why simplifying things is better, is because for small and simple programs, you unnecessarily don't complicate or don't override things. Things can be at many times very straightforward and concrete, and you can have concrete implementations as well. But obviously, in real life, in a real interview, make sure that you make interfaces or abstract classes for sure. Now, obviously, we heard a bit of interfaces as well while we were discussing about abstract classes. So let's see in deep about interfaces. As we saw that abstract classes were there to give method definition. If I have, let's say, engine, so engine functionality will be defined in the abstract method, and then I can have other methods as well which will not be implemented, which are called as abstract methods, and then the child will have to implement those abstract methods. But what is interface? Interface is, okay, I will just give a contract for a specific behavior. That's it. Like, he will not implement, again, there's a star mark to it when I say not, but yeah, he will not implement anything. So basically, interfaces focuses only on behavior and do not include any state. Right? Again, there's a one catch which I will discuss later on, that in Java 8 there's an update that we now have default we now have the corresponding default and static methods. Now you will see why they are useful, and you know how they help us to have backward compatibility and all that good stuff which can be achieved. And again, we'll see a very important interview question as well on top of it. So what's an example of an interface? A very simple example: interface, giving a name, and then abstract methods. That's it. That's your simple interface. Now you might ask, Arun, isn't it same as abstract class? We will see it. No worries. But let's discuss some of the examples. So we have a doc. It will implement that specific interface, which means it has to implement both the specific methods. If it will not implement it, it has to be abstract. Obviously, it is implementing it, so I'm good. And same way I can do for cat. The cat also will have to implement it. Now, if I just run this, I can just call an animal, and that can be dog or a cat, and then call the corresponding methods. Now, methods are same, implementation wise was different, the output is different. Now, the thing is that what is the advantage? Again, now we are thinking of advantage in terms of interface advantage, which you can think of maybe as an advantage of abstract class as well. But again, we will see their difference separately later on, right? Okay. Advantage of interface, obviously, decoupling. Like I can separate the method definition and their implementation details, which means okay, method definition is here, implementation details are given to children. I don't have to worry about the implementation details, and the child will actually handle it by themselves. Now, any new class which implements, our animal interface will give their corresponding own implementation. So even if I have a bird in future, they will give their own implementation. And this will actually standardize things, which means I defined a contract, the class behavior that will be same forever, which means if I want everyone to make sound, everyone will make sound because all of them are animal will have to make sound. If I want to define the contract, everyone will be able to make a sound. That's it. If I would have individually defined all these classes, there may be a chance that I won't be able to define this contract. Okay, they have to make a sound. If I want to define a contract, they will have to make a sound, so I have to keep it. Now, any disadvantages? Obviously, one thing which comes every time for any LLD question is complexity. The complexity increases a bit. You have to write all that good code, all that stuff. A bit of overhead in maintenance and readability, because obviously you have to track. Okay, it's a dog. It actually implements this and this. So you go here and here, and then putting up all the debug points and stuff. So again, things become a bit of haywire whenever you have multiple interfaces and multiple implementations. But obviously that's the catch of LLD, right? Okay, now comes the very fun part: abstract classes versus interface. Firstly, we will see their individual identity recap quickly. Then we will compare their differences and also pros and cons of both. Now, abstract classes, as we saw, that these classes cannot be instantiated, obviously. Again, the same goes for interface as well. But again, right now we're discussing all the qualities of abstract classes itself. And again, the main point is it acts as a blueprint, and obviously I cannot instantiate it. Now, I basically that specific abstract class, it can have abstract methods and also concrete methods. Variables in abstract class, basically it can have member variables which are final, non-final, static, non-static, which is anything. My abstract class can have literally any variable type. And also abstract class can have constructors which interface will not have, right? I can initialize variables in the abstract class, but again, you can do it in interface as well, but with a condition. That should be a constant, right? Which is static and final. While in this case, you will see I can have non-final as well. I can have non-static as well. So that's a liberty in abstract class. Okay, which means now we come on to interface. Although we discussed quite a lot of things while we're discussing abstract class itself, but let's see quickly interface as well. The prime beauty of interfaces: collection of abstract methods and their corresponding static final constants. Static final variable is nothing but a constant, which means that interface now, after Java 8, has default and static methods. Now, again, these are very, very, very helpful, and I will tell you how, but the glimpses, they help us in backward compatibility. But this is something which came in Java 8. Now, again, one more thing for your interview which can help you is interface can have a private methods as well. Now, again, this is just for your interview purposes. These can actually help you a lot. The biggest thing is that variables will be public, static, and final, which ultimately means they are constants, right? Now, interfaces cannot have constructors now because obviously, see, constructors are used, but interfaces are purely designed to define the contracts for classes and not to actually have their implementations. That is the reason constructors are not used here. And also, they do not manage or hold any state. Like, unlike abstract classes, they have the corresponding state, they have the corresponding attributes and all that stuff. They deal that, they handle that, they maintain that. This is not done by interfaces. Obviously, constructors are used to initialize the object states, but interfaces focus only on defining the behavior, and that's the primary reason why we do not have constructors in an interface. Obviously, the first question which might come up is, Aryan, with that, what you said right now, it seems that abstract class is super good. Then why would I ever need an interface? That is true. Interfaces are primarily used to enforce a behavior, and also providing some common functionality. Now, you might say, Aryan, why not? I can use abstract class. You can use. The biggest issue is multiple inheritance. that is the main reason why you had to reside with interfaces. But still, let's see. We have abstract classes. Dog will actually extend that abstract class. Okay, great. But I can also have non-static and non-final fields, which obviously interface cannot have. Interface will only have a static and a final field. While abstract class can literally have anything, non-static, non-final, like literally it can have anything. And thus I can use that inside those methods inside my abstract class as well. Now, the methods, as I mentioned earlier as well, any specific attributes. I can have any access modifiers. It can be public, private, protected, default, anything whatsoever. Cool. The biggest thing now which you might think of is seems good. We know all the distinguish, all the things between abstract class and interface, and technically I have repeated a lot of times now. So I ask you, when to use an interface? Obviously, you will think that first of all, there's no implementation needed. If that's the case, you will use an interface. For example, animal. If you think there's no implementation needed for make, sound, and sleep, you will use an interface so that your children can actually implement it. Second thing, if you think that you need to have a multiple inheritance, in that case, you will have to use an interface because a class can implement multiple interfaces but cannot implement or cannot extend multiple abstract classes. So this because of interfaces, I can have multiple inheritance because I know that if I have two interfaces, my dog class will implement both of them. But obviously, he has even if there's a collision in attributes. So if even if there's a collision in method names, still I will have to implement it. So I will do by implementation by myself. So that's the beauty of using interfaces. Now, then the question comes in that when to use abstraction then? Obviously, when you have to define a template or basically any standard implementation for the class to follow. Obviously, when I say standard implementation, which means you are hiding some implementation from, or maybe hiding some implementation or any of the values from your children, then you know that you have to use abstraction. Now come to the important interview question, because now we have discussed entirely everything about abstraction and interfaces. Technically, now you should be able to answer all the questions, but again, there will be a couple of them which you will see right now, especially regarding around default and all that stuff. So, abstract class. Now, they are used for common functionality. Again, that's the question which comes up again, that okay, what's the difference between abstract class and interfaces? Just as a summary, we are kind of summarizing it in one point. Abstract classes are used when you have to share the common functionality, right? Interfaces are used when you have to define the contract. Again, you might say, are in contract and common functionality the same? Common functionality is functionality which is implemented functionality. Shared piece of code is a common functionality. Contract is just the definition of a method name. This is the behavior which you will have to do, which means you will have to make a sound. That's a behavior. But implementation wise, I can actually say okay, it can be constructor as well. Where I can have that implementation. I can have these variables, attributes which I can put up on the basis of my constructor and all that stuff. Now, interface will say okay, play. The pet will play. That's the behavior which the pet has to follow, no matter what. Now, if you remember, there was one thing which we discussed in previous sections about super. Although we discussed about this, but super, as we saw earlier, that super goes to the parent class and call its constructor. So I'll go to my parent, which is animal, and its constructor. This is what super is calling. So technically, I'm calling this thing of my parent. That's super. Again, this is exactly what we have seen also previously. Next question. Can an abstract class implement an interface? Technically, yes, because no one is stopping you, right? Yes, the abstract class can implement an interface. Now, why it will do that? Obviously, to avoid that corresponding partial implementation, which anyone could do. For example, I have a pet. I can have an animal now that implements a pet. So obviously, that animal, again, don't go into names because pet is actually an animal, so animal should not implement a pet. But still, go with the feel of the method or of the wordings that I will have this specific class. It will have a method which will play. Now I know that everyone will be playing. every of the animal will be playing. So if I want it that, okay, any specific class in future should have this implementation ready and no one should implement it again and again. Thus, I will define or I will override this inside this animal class by implementing this pet method. So I implemented this pet interface, then I implemented or override this specific method. Anyone in future, dog, if it is extending an animal, it already has this play. So it doesn't have to do anything else. That is something, reusing piece of code. Don't repeat yourself. Dry principle is followed here. Now, next question. Why can't we instantiate an abstract class? See, abstract class in its spirit and soul is actually an incomplete blueprint. So there's no point of instantiating it. Now you might ask Aryan, just previously we saw that abstract class can also have no abstract methods, which means that abstract class can literally have just one method, which is perfectly fine. So why can't I instantiate it? See, even if it has a method which is not an abstract method and it has its implementation as well, but still writing it as abstract defines that the person who wrote this wanted it not to be initialized. For example, animal. I want this technically, not logically. I can define the object of an animal. So what's the point that I will allow the user to even have its definition? That is the reason I will mark it as abstract, because I know even though I have all the implementation of animal, all the implementation I have there right then and there, but still I will mark it as abstract, which means that no one should be able to make its object, and that is the essence. Although we cannot instantiate it abstract class because we don't want it, but still abstract class can have no abstract methods as well. So again, this is exactly what it is shown. I have animal, and obviously if it has an abstract method, I cannot initialize it, which means I cannot do something like this. Cool. Next question. Any limitations of using abstract class over interfaces? Obviously, single inheritance only can be achieved by abstract class, while multiple inheritance can be achieved via interfaces. That's the biggest thing. Abstract class animal, and I have another abstract class mammal. I cannot do a multiple inheritance for this. Not possible. And that is the reason, that's literally the biggest reason why you actually use a multiple inheritance, or I should say multiple interfaces you use, so that you achieve that multiple inheritance. Cool. And again, if I use the same thing, interfaces, animal, pet, I will actually have a dog where I can now implement it, because now there is no technical collision per se, because I have sound, I have play, and I can simply implement that. But now you might say, Aryan, what did you just show me right now? Isn't it a violation? See, what I showed you right now is actually a default method. You have a common method. And even, although we'll discuss this later on as well, but if you have a default method and then you have an implementation for it, then you will have to, this common method has to be overridden no matter what. Again, we will see this later on as well, but this is the kind of thing which came in Java 8, which is a default method. Why it came up? It came up for backward compatibility. Why backward compatibility? We will see. So, okay, let's see right now. So, what happened previously was that we have an interface and multiple classes used to implement it. Okay, I implemented this. Now, in future, let's say I wanted, okay, one method should come into every other class, like every class, but let's say not leaving this. So technically I will have repetition here, here, here. But then I also am saying, okay, this is an interface. If it would have been an abstract class, right? I would have defined that method here, which means it would have automatically came here, 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 and here as well. But now I want a middle ground between interface and abstract class. Thus, I brought up default method. With default method, the child would not need to implement it. If it came down, great. If not, then great. So child would not be needing to implement it, and also it will have a default implementation. But the benefit of interface is still there, because the con of abstract class was I cannot have multiple inheritance if I have abstract classes. And that is the reason people tend to use always interfaces rather than abstract classes. So they try to bring a common ground that, okay, in interface itself, we will give a functionality of default methods so that you can have a default implementation so that you will be good, right? And every of your child who has implemented your interface will have that default method or default implementation. If you want to use it, override, it's up to you. Do whatever you want. So how this resolves that diamond problem? So if you don't have any conflicting methods, if it would have been a name of common method one, if it would have been common method two, then it is not a conflicting method. In that case, you don't need to have an implementation. Not required. You still can do multiple inheritance. But if the names are same, then you will have to do the implementation. You will have to do that. That is required for sure. So as to get rid of that collision thingy. That is how in Java 8 we were able to achieve multiple inheritance, and also we are able to get some default implementation as well of a method. Cool. Let's continue forward. Next question. When should you not use an interface? Give a simple practical example. Now, as we saw that if we have some common functionality and I want that common functionality or state to be shared by everyone else, I will not use an interface, because in an interface, I will not be able to achieve that. Now, you might ask, Aaron, I can achieve that by default. Yes, you can, but that's not the actual root of your interface as interface itself. So let's say you have that eat. Obviously, you would be having some common functionality to it. When I say common functionality or a state, there is much more than just having a method, right? As we saw above, there can be a secret, which I want. I want to maintain a state. So there are multiple things, much more than just having a simple method implementation. There are many restrictions on an interface still, because this variable can only be constant. I cannot modify this variable. So the things cannot be changed in an interface. And that's the biggest issue with it, but also giving the advantages of multiple inheritance. Next question. What are default methods in Java interface? Exactly, we have seen already everything, but again, default methods basically are the methods in interfaces that have a body. As we saw that we have a body, we have a specific body to it, and ultimately anyone who implement interface, they don't need to override this sound method. They can, if they want, they can, but they don't need to. What it helps us, it helps us to have that backward compatibility without breaking any existing implementation, as we saw in the previous diagram as well. Now, next question. What's the difference between abstract methods and default methods? Both look same. Basically, abstract methods will have no body and it must be implemented, but default methods will have a body and they optionally are overridden. This is an abstract method. This is a default method. It has a body, it doesn't have a body. It needs to be overridden, it doesn't need to be overridden. That is a difference. Now, why do we need default methods in Java? We saw earlier as well, while we're discussing the image, that it helps us to add new behavior while keeping things backward compatible. And again, why not abstract classes can be used? Obviously, because it will not have that multiple inheritance supportability to abstract class. So we use interface with the default method to have, the fun of both the worlds. Because interface with default methods have that flexibility, but also avoid that diamond problem. Again, when I say avoid it, which means it will still have it, but it will not give you it will not give you an error of the, okay, you will not be able to implement two different interfaces. You will be able to do it. You just have to resolve that collision which will come up. So if I have interface, a simple abstract class, I can have that simple eat method. And again, because it's a default, don't implement it. Now, next question. Can again, if the folks who don't know, I just show the same thing here itself, that if I have two classes, m1 and m2, even if you can see I have two classes, the methods are different, still I cannot write this thing because I cannot extend two classes. Not possible. Although you will see, Aryan, it is unnecessary, right? I have m1 m2, I have two different methods, but why I'm not able to do that? That's the biggest issue with abstract classes. While if I had interfaces, if I had m1, m2, I will be simply able to implement those. But if I have A and B as interfaces, I have same methods. I will still be able to implement A and B. It's just that I will have to override the method M1. There's no other option. I will have to override it, which means I have to implement that specific method itself. Next question. Can a class implement an interface without overriding its default method? Obviously, yes, we saw many times that it is used for backward compatibility and we can do that. And obviously, the default implementation will be inherited by all the corresponding subclasses. And also, that specific method can be overridden as well by any class. So dog will have this sound method and he can override it as well. Question number 10. What happens if a class implements an interface with a default method and also inherit the same method from a superclass? So I have animal, I have mammal. It has sound, it has sound. Dog, it extends mammal, it implements animal. What will be chosen? This sound, this sound. So it is always chosen of the parent class. So it is always chosen for the parent class which we have. So this takes the priority. So I will simply see this is the mammal sound. This is the mammal sound. Next question. What happens if a class implements two interfaces that have a default method with the same name? Obviously, we will have to resolve it by ourselves, which means we must, the word is must here, we must override the method to explicitly resolve this ambiguity. For example, if I have a dog behavior, if I have a cat behavior, if I have animal processor which will implement both of them and having the same default method, I will have to override that specific implementation of make sound. There is no other thing which can actually work because I will have to resolve that conflict. Next question. Is it possible to override a default method and make it abstract in a subclass or interface? Technically not, because default method, it cannot be overridden and make abstract. Again, but the entire reason is that default method is defined, like it's, let's say it's once defined, so overriding that specific implementation should have to provide its concrete implementation. I cannot just let it go. Okay, let's be abstract. So if I have a default method, anyone overriding it, anyone implementing that specific method, they cannot keep it abstract. Okay, no, like, no worries, because technically it was a concrete implementation. So any of the some classes will also need to have its concrete implementation itself. It is not backward such that okay, giving a concrete and then giving not concrete, not possible, right? If concrete is there, concrete will be there next. If non-concrete is there, then concrete will be there, then it will follow that concrete behavior. So once concrete will have to remain forever concrete. Next thing, can default methods access instance variables of the implementation class? Technically no, because obviously this interface will have to write anything. Whatever he write inside it will be defined whatever I have a parameter to it or any internal logic. Anything can be there for this method. Now it is going bluntly as is to the child. How would this method know what is there in my child? Right? It will never know. So how would this implementation, how would this thing ever know what was inside my child? It would never. And that's the reason my default method cannot access the instance variable. Right? Again, of my implementing class, again, if you are in interface, you can access your own constants, but not of your implementing class, which is dog in this case, because default methods are actually stateless and they only work with their parameter and the internal logic which they have given. Cool. Next question. What are some limitations of the default method in comparison to the methods in an abstract class? Obviously, we saw that default methods cannot have any instance variable. They can only have that, constant variables which we have. Obviously, default methods cannot use super because, again, like to use super, like they're kind of referring the implementing class of parent, but it will not have it. So yeah, they cannot use super. The biggest thing is abstract classes can have constructors and fields, but interface cannot. And that's the limitation. And that is the main thing. As we were seeing stepwise, pin by pin, we were seeing the differences between the corresponding abstract class and interfaces, pros and cons of both of them we were seeing simultaneously. Cool. And as you can see, the one last example for it, that we have an abstract class where we have instance variable. Again, you will see that it can have literally anything, like no access modifiers needed to it. Why? Obviously, I can have constructor as well. I can have abstract methods as well. I can have a non-abstract method as well. But interfaces, they can have default methods. They cannot have, non-constant variable names, which means that I can have variable names, but they need to be static and final, which ultimately says that they should be constants. I cannot have a non-constant variable name itself, and obviously I will have a default method. So you see that interfaces are a bit limited in what they can do. Obviously, they cannot have constructors. They cannot. Again, you might also ask that, Aryan, what's the need of constructors itself? When we cannot initialize my specific abstract class. Again, the same point comes. Constructor main purpose is that before we actually initialize the object, whatever needs to be done can be done in the constructor piece of code. So if animal has multiple children to it and everyone have their own implementation, and that is very common implementation for multiple of them. Again, I'm saying common piece of implementation as well. So it has common piece of implementation for many of the constructor logic. I can simply call a super and then pass the argument, and thus I will have the common implementation inside my abstract class itself, and with that I should be good to go and not repeat my code. And that is the reason I have a constructor inside my abstract class. But obviously abstract class cannot be instantiated because I don't have the presence of certain methods. Cool. Okay, lastly, conclusion. Abstract class and interfaces is what we saw in this specific section. Primary purpose is making things flexible, majorly reusable, and also maintainable. And thus, make sure that abstract class and interface brings up most amount of interview questions in any of the interviews, like literally any of the interviews. And whatever I taught right now can come up as an interview question. And again, all these questions are actually an interview question itself. We discussed 14 questions and literally all are based on what we saw just now. Cool. Let's go to next lecture in which we'll see access modifiers. Okay, so now we're gonna see access modifier. What is this access modifier? Access modifier says they are gonna restrict the access to do some operations, which means they'll control the visibility and access of classes, methods, and the corresponding variables in a specific program. Ultimately, the essence of them is that they prevent the members or functions of any class from tampering with another class with those restrictions which can actually help, okay, give us specific access to anything. Now, before we start off, we will take a simple structure. This is the root of our project. Then we have a package called as demo package, which has a class where we actually write the actual testing function or testing code in this class. Then we have another package, utility class, package 2. It has all these classes, default class example, private class example, protected, and public. Because these are the list of access modifiers which we have. Now you might ask, Aryan, why are you teaching it right now? Because now you have the entire idea of inheritance, encapsulation, all that thing you have an idea right now. So this is the right time to teach about the access modifiers in detail. Because so far we only saw, private and public mostly, although just at a glimpse we saw protected as well. And also we saw default, but still. Now we're going to have a very in-depth of how the entire package or how the entire access modifiers look like. Now, as I mentioned that in the utility class, we have these 4 classes for their corresponding respective public, private, protected, and default testing. Now, let's see how we will do it. Public. Public says that it is accessible from anywhere in the application. It is a package, it's a class, it's a subclass, any class. I can access public anywhere, literally anywhere. So we use public modifier when we want the element, it can be a class, method, or a variable, to be globally accessible, that anyone can access it anytime. For example, in the public class example, I used a public. Now this thing can be literally accessed anywhere. So in my demo package, I simply wrote a program in which I am making an instance of this specific example, which is the public class example, and then I call this public method, and it simply worked. That's it, as simple as that. So basically that display method itself in public class example, it can, like, again, as it's declared public, now it makes it accessible everywhere, across all packages, across everywhere in the program, any package whatsoever we have, and also without any of the restrictions at all. Now, as you can see at the output, it's a public method. Next one is private, which we have been seeing a lot also previously. Private says that okay, it is not accessible from anywhere in the application, like literally from anywhere. If it's the same package, no matter what, again, same package, a child class, or different package, no matter what, it is not accessible anywhere. Not accessible anywhere. It is only and only accessible within the same class. That's it. That's it. Which means that if I take the example again, so this is the current class. If I declare anything private, it can only and only and only be accessed in this same class itself. That's it. In this same class. It cannot be even utilized anywhere in this package or outside this package, nowhere. So even if I try, let's say outside the package I'm trying, and I make an instance of this specific class, I tried. It will say, bhai, it's a private access. You cannot do it. You cannot access it. And again, you can see in the logs as well. You cannot access that. Okay. Next is protected. Now this gives us a liberty, a lot of liberty. What it says, it allows the access members within the same package or from a subclass in another package. So why it is useful? It is useful to enable controlled inheritance because subclass in other package. In the same package, I can access it because same package, same functionality, same things, access it. But in different package, I can still access it, but it should be a subclass. So this gives us a controlled inheritance, which means that allowing the child class to reuse and extend the parent class functionality while keeping it hidden, while keeping it hidden from unrelated classes. Because if it's not a child class, it is unrelated. If it's not in the same package, it is also unrelated. In that case, I can use my protected access modifier. So ultimately, it is used in the scenarios where inheritance is the primary key design pattern which we are using. For example, in the same thing, we have taken protected class example. I have a simple method which is protected. So obviously, in this package, in this utility class package, I can literally use it anywhere. I can use it in the same class. I can use it in any different class, provided it's in the same package. But also, I can use it in any different package as well, provided I will have to, like, basically this class should be a child class of this class. But here in this case, we see we are in a different package, but this class, demo class, is not the child class of my protected class example. So obviously it will say that, bro, this is a protected access and you cannot actually access display, and ultimately you will screw up. How to access it? Obviously, demo class should make sure that it extends the parent class, which is the protected class example, which is this class. Now I will be easily able to access that protected variable, or I should say method. And that's how you can solve it. Next is a bit more restrictive than protected and a bit luxury than private, which is default. Default says that members with this access modifier is accessible within the same package, but not outside from it. So if you see that, isn't the protected also same? So protected's mentioned that I can access in the same package, and also outside it, it's just that it should be a child class of this class. But he says, okay, I can access the same package, that's true, but I cannot access from outside. Even if it's a child class or not, I don't care, I cannot access it. So you see that default is a bit restricted than protected, but obviously a bit, in luxury than my private. So ultimately, it says the functionality is available for closely related classes within the package. Because obviously, if there's a package, so all the classes are technically closely related. And everything being hidden from any other part. Even if it's a child class in the other package, basically anything in the other package is hidden from you. So this helps us to limit access at a specific package level and not going that access and not moving that access outside. So this is primarily you will use in the production code basis. It is used as an internal helper class because helper classes are in the same package and they will help in the current package itself and not outside it. Again, it can be helper class, methods, or any variables that do not need to be exposed outside the package. For example, in this case, you will see that I have a default class example. A simple thing, default method. I can simply try to go outside the package. Oh, I cannot go outside the package. This will say, bro, you cannot go outside the package. But if I try to stay, again, as I show, it will not go outside the package. But if I try to stay inside the package, yes, I will be able to access that. And this will simply work. So as summary, what we realized is that a public can be accessed in the same class, in the same package, in the same subclass, also globally anywhere in the entire application. I can access public. Protected can only be accessed in the same class, in the same package, but also in a different package, but should be in the same subclass. Obviously, there's no globally now. Globally is only for public. Next is default, which is a bit lesser than protected, but higher than private. Why is it bit lesser? Because now it is in the same class, great, same package, great, but not in the subclass. When I say in the subclass, I am saying in a subclass in a different package, not. And obviously, not global as well. Lastly, private, only in the class, that's it. Nothing else, nothing, nowhere else. Same package, same subclass, no, like nothing. So this is how this access are being reduced like this. Public maximum, then protected, then default, and then private. So now you know that these access modifiers help us in visibility and accessibility of classes, methods, or even variables. Primarily used to secure and maintain applications, and obviously making them that only the people who are required or who have to use it, only they can use it and no one else. Cool. Let's go on next to the class relationships. So now we will see class diagram starting off with inheritance. So basically it is a relationship. So basically a subclass inherits the properties and behavior of its parent class. Already we have seen what inheritance is. So we know that a dog is basically an animal. The properties of dog will be inherited from an animal. And basically a subclass extends the functionality of its superclass. So any of my superclass, and this is my corresponding subclass. To represent inheritance, we show it like this. And you can see this is the exact same piece of code which we had been seeing so far. Next, we have is association. Again, this is important. This one is important. Next one is association. Association simply says that one class knows about the another class. Or basically it uses that another class. It's kind of a friendship. Two entities are aware of each other, but obviously they are existing independently. A person has a car. A person uses a car. A person owns a car. A person knows a car. So this exactly says a simple association relationship. There is a car, and then we have a person. The person has a car, and that what we show as a simple dark dash. Cool. This is your association. It is also important. Next one, we have aggregation. Again, this is not important. Even if you don't understand it, don't be confused. It will not be required anymore in future as well. But aggregation simply says that whatever relationship has a relationship you had, there is a slight catch. The parts, they exist independently of the whole, but they are still grouped together by some container. For example, I have a team. The team has multiple players. Now, team has players. So it might sound like association as what we saw just above. But still, team has players and both can exist independently of each other, so they have categorized it as a special case named as aggregation. So if I talk about, kind of the differences, but yeah, before differences, let's quickly say that all the players exist independently of the team. They can come or leave the team as and what they like. But the biggest thing about aggregation is that the team holds and manages the player instances. But again, the player also are not solely dependent upon the team itself. So, as and when, obviously, you will have a question. Aggregation and association. What's the difference? Association is a general relationship, kind of a friendship with no ownership implied, like literally no ownership. But aggregation is more specific. It's still a hazard relationship, but where one object here in this team, it contains or references another object, which is players. And again, they still can exist independently of a whole. Again, as I mentioned, it might sound very similar, and in many cases, you might end up thinking, Aaron, what should I say, association or aggregation? I'll highly recommend forget about aggregation. Always look for association. Next, we have composition. Composition is nothing but aggregation with full ownership, which means that if the whole is destroyed, the parts cannot exist independently. For example, we have a house. House has rooms, but obviously room cannot independently exist. Obviously, there will be a house or a hotel or something. Room cannot exist independently. And that is what is called as our composition. Again, this is also never used. You can ignore this as well. In place of these, you can always and always use your association, which we saw right here, which is much more easy, convenient, and beneficial for long term. Again, same way, you can see the corresponding code also on the left side, which just represents, okay, a house can have a room. Again, that room can be literally anything, but the room independently cannot exist. So it's a like basically this thing, basically the room object does not exist outside the context of your house. Now, coming on, next is dependency. Basically, it's a very temporary relationship where one class uses another class. That's it. Just I say that I have a document, and inside document in one of the methods I have printer being used. So document is using printer. Makes sense? Document doesn't have a printer. No. Document temporarily for one of the methods uses a printer. This is called your dependency. When any of the methods has one of the argument where it is using another class. So basically this document, it does not store a printer, it does not has a printer, but basically it uses kind of that specific printer. Now again, this relationship is transient because whenever the method is called, only then the relationship implies. And that's the ultimate case. Again, a quick thing about the current dependency and the association, which is pretty blunt and pretty simple, because association says that objects are passed and have a has a relationship. As you can see, a person has a car and a long-term relationship which we can have. Dependency, on the other hand, these methods, these objects are passed as method parameters and can only be used in the method scope. And again, obviously, it's a short term because it is only called when a method is being called. Now, lastly, we have realization. Basically, it represents a relationship where class implements an interface. That's exactly what you are doing. If we have a payment interface, credit card payment and a cash payment basically implement this specific interface. That is nothing but we represent by dotted lines and then like this. This is simply implementing again the code you can see on the left side for it. Now, if we sum up everything, what we can say, okay, we have a book. Now, my ebook basically inherits from book. So this is inheritance, right? Ebook inherits from the book, it is inheritance. Then obviously book implements readable, thus it is realization, which we saw just now. Obviously, book has a author. As you can see, book has a author. So I can simply say it is association, which you saw in the number 2. Now, any reader uses, the book. So obviously, this is nothing but your dependency because this read book method will be used when obviously, it's a temporary dependency. This book will be used whenever a read book is called. That is, it is called as dependency. Obviously, reader, reading club. Reading club has multiple readers. Now, you might ask, is it a hazard relationship? It's a association or not? Obviously, you will see that reading club and readers both can exist independently. It is same way saying a team and number of players. So we can count it as aggregation. Again, as I mentioned, don't go into all this. You can simply assume this to have a hash relationship as well. Don't go into all this, nitty-gritties. You will end up, you will end up going wrong if you will end up learning about many things. So I'll just tell you in the very end also what are important. But yeah, lastly, this thing, although I could not find anything which could club up all the things together, but this is not a composition. Why? Because library and book can exist independently, which means, okay, library although will have books, so library will be needing books ultimately, but again, books can exist independently, but again, still, we can think of different case example of composition, but this is not exactly composition per se. Now, lastly, just as a summary, what is important or what you should remember technically is anything inheriting any other thing, you should remember inheritance. Anything implementing any other thing, you should remember realization. Anything where you have a has a relationship, book has an author, and all that stuff, then you should remember association. And lastly, anything being temporarily used, so reader uses the book, dependency. So you should remember only these four. That is ultimately what you will be needing in future. These you will identify, when things are tightly coupled, okay, this, when they are not, then it is, diamond empty bracket. Cool, but still, I always recommend that make sure that you only know about these. And again, it is not necessary for your LLD interview because you will not have that much time to create all these diagrams. This is not your HLD, right? Round. It is actually your LLD round itself. And in that, you have to write these classes. And what you will be doing in an interview, as what we saw in the first lecture, if you don't know, go and watch it. We realized that we will write the classes, which is the entities, and the corresponding, attributes or methods, and then we'll simply go on. We just write code, and that's how we'll show the relationships, and not by making all these diagrams. But still, it's good to know about them because in future LLD code problems, we will be showcasing you all the diagrams. So it's good that you know about all of these. Cool. Let's go to next lecture where we will learn about generics. Now, generics and wildcards are the last thing in your OOPS, which will be very important for your any interview or in general for your LLD itself. Now, as the word itself says, generic. It will make your code generic to handle different types. What is the types? Obviously, let's say if anyone asks you any question, right? Write a DSA code for just finding the middle of linked list, or let's say they ask you to find the middle of a binary search tree. Now you write the code. Now you would have assumed that each node would have a value which is integer, right? Now, when you wrote the very good code, they ask you, okay, now assume that this node value can be either integer or a float or let's say a double. Now, how will you modify the existing code? Either you can make 3 copies of these functions, which will one will handle integer, other will handle float, other will handle double, or you can write one piece of code which is a generic piece of code. That is the primary use case of generics. And again, the brother of it is wildcards. We will see what exactly there and what are their differences, but let's start off. The biggest and the best possible benefit is that it introduces type safety and also reusability in the code. The reusability we saw, type safety we will see later on. Now, we can make anything generic. When I say anything, I can make classes also generic and methods also generic. But before that, as we saw, okay, we can make this, but let's see what exactly is a generic. As I told you, that I can use, if I'm writing a function with maybe some fixed kind of thing, okay, it is integer or a float or a double, rather I can shift it to use generic. Thus, I can just write one piece of code, and that would be good. So it is kind of way to parameterize the types, which is that I can have different data types and I don't need to specify any exact type at the compile time. Rather, anyone, me or anyone else can just give, just t. It can be like literally anything. The type can come in by whatever the program or the person who wants, whatever the type he wants to put up. With that, you will ensure the type safety. Now you might ask, Aryan, technically if the types are unknown and type can come up anytime, anywhere, then how type safety is maintained? That's a good question. We will see it later on, but it will maintain the type safety, which means that if it is defined as string, it will be string no matter what. It cannot be then changed to integer. We'll see that with the example as well, but yeah, this is how it will maintain the type safety. It reduces the code duplication, which we exactly saw just now by taking the example of finding the median in a binary search tree, and then also improves the readability of code because obviously the code is now less cluttered, having just one piece of code which can be used multiple times. Now, we started off with generic types. So firstly, we'll see generic as a method. So we can have a generic method. So as you can see, this is a simple method, generic display. Now, to specify that it is a generic, it is a type parameter t, which I have defined. And as you can see, my t is an argument itself. Now here, whenever I call this generic display, I can call with literally anything. I can call with 11, which is an integer. I can call with a string. I can call with a double as well. It will automatically go and will put up the corresponding type. Now, this, as you can see, that same piece of code was able to handle any type whatever I wanted. Same way, we can have generic classes as well. Now, obviously, in generic classes, I can have more than one types. What I mean by that is that, as you can see, this is a class. Same that this is a type parameter. Now, as you can see, as this class has type t, I can leverage that t anywhere in the class. I can have t as a return, like t as, one of the type of an object. I can t as the parameter type. I can t as the return type. Literally, you can see that this t, which is kind of generic in this case, is being used anywhere. Whenever I will initialize the corresponding object, so I'm making a new object, I'm defining the type, and this type will actually go in this t. What this ultimately says is, now as I'm initializing a new constructor, or new object for the specific class, then I will have test as a class instantiated with integer type. So this is integer. This will be replaced to integer. This will be replaced to integer. This will be replaced to integer. Now I'm calling the constructor with the argument 15. 15, considering it's an integer, it will go inside and it will simply work. That's how you saw that it maintained that specific type safety. That any operation now on this specific I object will only be able to handle integer. I cannot do something, okay, just putting a string here rather than, and putting up a integer and then putting up a string here. No, I cannot do that. I will have to put up an integer only, because now I have maintained that type safety, and this is how you maintain that type safety. Cool. Now let's continue. The only thing is that, as we saw earlier, was only one parameter. We can also pass multiple types. That is, if we can have tu, right? With that, you will see the same thing. As you can see, the code looks exactly same. Now I can leverage tu both, right? I can simply say, now whenever I am trying to initialize it, I will just say, okay, now type is string integer. So it will automatically map it. This will be string, this will be integer. And now everywhere in the code, this should follow. So if obj, I am trying to apply any operation on this obj, it should follow that its t should be string and its u should be an integer. If you try to do anything else, it will give you compile time error. And that is the best benefit that you will get the type safety to it. Now, generics only work with the reference type. What I mean by that is that if you want to pass an int, which is a primitive type, it will not work, right? You cannot use this int, char, boolean, no. We cannot use this primitive data types. But obviously, we can use a integer array because it's a reference type. That's the one thing which you always should know. Now, obviously, you could have seen the benefits so far of generics. They are pretty insane. First of all, type safety, as we saw, that it prevents those runtime errors which we can easily catch at the compile time. For example, int string. Obviously, this will be int. So everything will be int here. This will be string as I've defined it. So everything will be string here. So the type is fixed now, string here. So obviously, these cannot be interchanged. If I try to, assign it, or maybe just even if I, let's say, have some setter methods where I will just put up anything. If I, let's say, define iobj, but if I put something inside which is a string, this will not work, because obviously now the operation should be bound with the t, and t is right now integer itself. So this maintains that type safety. Now, next thing is code reusability, which is obviously, as we saw earlier as well, that we can have multiple data types as a requirement, and I will not do code duplication, and ultimately I will be good to go. For example, in this case, I have, let's say, integer array here, I have string array here. I don't need to do anything. I can have a t array. That's it. Thus, I don't need to duplicate this code for integer array and a string array. No, not required. I can simply use this one simple function which will have t, and that t can be integer or a string and can be changed and can be used the same function. Now, next thing is obviously readability and maintainability increases because now you have to maintain only one piece of code and not two pieces of code. And also maintain readability. For some people, it can be a bit tricky who are starting off with generics, but usually as you are familiar with generics, you will see the readability also increases. For example, obviously in this case, if I have a generic piece of code, it is easy to maintain. I just have to maintain this at one place and everything else can be done, maintained. Obviously, I have explicit declaration here, as you can see, string, which is obviously easy to maintain and read as well. Again, as I mentioned, you can not define anything at all. That also works, but technically it is bound to give you issues considering if you not handle it carefully. Now, elimination of typecasting, because now generics will help make the error appear at compile time than the runtime. So you don't need to typecast things separately because typecasting is required, when you have some type but you don't know what the type is, then you typecast it, then you know, okay, this is the corresponding type, and then you got this type. Now, whatever on runtime this variable as is filled as, if it is able to cast it, then great. If not, then you are screwed up. So all these typecasting issues result in a runtime error. But obviously with the generics, I know the fixed type t, and that is only what I am also returning. So this will, if I'm on runtime passing it as a string, but then here I'm having that operation which is integer. Obviously, this will help me say, okay, not possible, simply not possible, and this is how I can go about it at compile time itself, which is ultimately, as I can see that if I don't define anything, right, I simply try to add 10. Obviously here I'm not defining any type, so I'm just going about, okay, go about and do and try anything, so it will try to add 10. It will give a compile, like compiler will allow actually. But if I have a specific type defined, that that type is, let's say, integer, then, or let's say if it's string, then if I had to try a 10, it will simply give a compile time error. But without any type specified, it will simply allow this. At runtime, I'll get the issue, and I'll simply say, "Oh, this is class exception, and this is not allowed." That is the primary case, and this generics will help me in typecasting of things. And with the typecasting at compile time itself, I will get this specific issue. Oh, sorry, bro, you were doing wrong. It was a string. You can only add a string, and that's how I can get rid of all the things. Now, what are wildcards? Because you saw generics. Generics was, T, 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 all that stuff. You would have also seen something like question marks. What are these? Technically, wildcards are some special symbols which obviously are used in generics to represent unknown type. What is question mark? Question mark, how you use a question mark? Whenever you don't know things, this is unknown type. So ultimately, this unknown type can be literally anything. I can simply pass in apples, integers, I can pass in strings, integers, anything I can pass. So this is what an unknown type is. Now the biggest question which you might end up thinking is, Aryan, then I can also pass a t here, right? I can just simply say, okay, it can be a t as well. Still I can pass my string and integer. That's true. So what's the use of it? We will see it just soon. But before that, let's see what types of wildcards you have. One is unbounded wildcard. What it simply says, okay, a simple unknown type, and is useful when the type is not relevant to the logic. What I mean by that is, okay, a simple unknown wildcard, like simple unbounded wildcard, simple unbounded, which is okay, no foundation. You can have literally anything whatsoever you want, and you can simply read off stuff. The type is literally not relevant to the logic which you have inside it. And again, what I'm speaking right now is a very important distinction between a generic and a wildcard. That type is not relevant to the logic. That is a very important point because this will be the main distinction between generics and wildcards. So what you do here, you are saying, okay, the type is not relevant because ultimately I'm just printing it. So for me, the type is simply, anything can be there. Next type is, you saw earlier, we saw unbounded wildcard. Next, we have upper bound wildcard. What it says is that all these generic class restricts the type to the type or its corresponding subclass, which is that it is useful mostly for read-only operations, where we actually specify the type, and that specification of type is not required. What it means? It means that, okay, you just say question mark and then it should extend number. It can be integer, double, anything, float, which any type which extends a number. So you have a number, then anytime which extends a number, which is integer, double, or float, or anything, this is called as a upper bound wildcard. What I can do for it? Obviously, they are saying this is good for read-only operations. Because obviously you are trying to go one level up, so it is good that you only read things. Don't write, because obviously if you end up writing things, then integer versus double can actually give you issues. Because again, integer is different, double is different. So obviously, just write things down when you're going higher, upper, when you're going level up. Just make sure that you are kind of reading things and not writing things. But what I mean by writing, you will see just now later on. But again, this simply helps this is called as upper bound wildcard. Now, why this is much better than unbounded wildcard? Because this will have some restrictions. What is the restrictions? This says that if I have some string, obviously I cannot add that, like I cannot just simply pass that specific string list. No, because string does not extend a number. Double is a number, integer is a number, but string is not. So this will say a simple error, incompatible type, list of string cannot be converted to list of question mark, extends number. And that's how you know. Next one is lower bound wildcard. See, just opposite of upper bound wildcard. Restricts the type to type or its corresponding superclass and is useful for write operations. As you know, that this is now more restrictive. It is your lower bound, which means that now question super integer. So now you are now going a bit one level up. So now you are at number. Obviously, you are at more generic stuff. So you can just simply say, okay, list simply add 42. Now you can simply add a 42 because obviously number will simply work. So this is a write operation which is you are writing in the specific list. And again, this is, as you can see, it's a bit opposite than what you saw as a upper bound wildcard. Now, that's a simple thing about wildcards and generics. But the biggest issue is, or the biggest point is that what's the difference between wildcard and generics? It is exactly the same as what we discussed. Just summarizing these points, generics has the type of the corresponding class or the method, while wildcards have unknown types. Like, literally. Flexibility says that generics are literally fixed. They have that type safety linked to them. But wildcards are literally flexible. You can just pass in any type whatsoever and inside the function as well, do anything whatsoever. Use case for generics is whenever you need strongly typed, reusable code. Wildcard use case is more of, again, when you need varying type. You want to read things, you want to not do much things. Again, using wildcard should be avoided at many places. But again, if you want to read stuff, just wildcard can be more than enough. Now, the biggest issue, when to use what? Obviously, we have told it earlier as well, but still, when to use generics? Obviously, as you saw, that if we need type consistency, that all argument return type should have the corresponding same values, then we use our generics. What we mean by that is that obviously you can see that here I have a list and I want to add things on that list, and again this I want that it should be of type t itself. Thus I can type add type t, which is the first element. I can add second element as well, because they have same type. And this is how the type safety or type consistency is achieved by using generics. And you can see here I'm passing string list of type string, apple, apple, both are strings. Here I'm passing integer list and then integer, integer. Here I'm passing double list and then double, double. Here I'm passing person list, person list and then person, person. So this maintains the type consistency and thus we have the type safety as well. Now, wildcards, that's a catch. Wildcards do not allow additions because the compiler cannot guarantee the type safety for unknown types. What will happen if, let's say, you have a wildcard which you have and you have any object? You cannot add this element inside this list. No. If you try to do it, compiler will simply say, I cannot add to, list of this thing, because obviously compiler is not sure. Is this actually feasible or not? That's the reason the compiler will simply say, no, I cannot do it. But if you would have said, okay, this is T, this is T, then you can simply add this specific element inside this list. because we are using generics rather than using wildcards. So generics provide a known type. Wildcards are for read only, and that we have said a lot of times. Wildcards are only for read only. Now, another big thing is that why we use generics is when we have specific type in return, which means that you need to return an object that specifies, the type, and we can use generics rather than using a wildcard. Obviously, in this case, we have a type T, which we have to return. So this is the corresponding return type. It is feasible, it is possible, because now we know, okay, the list is being passed, the list whatever is being converted, and then I'm just giving it the list first element, and that will be T itself because the list was of type T, and it is feasible. So that will work. And again, if I would have used a wildcard, then even if I return that, I would not be sure what I'm returning. And that's the reason you would never be sure. And again, that is the biggest issue, that the type should be the actual wrapper class and not an object type. Like object type is very generic. Everything is an object. So you are returning very generic thing. Now, when this is being returned, you will actually end up playing around with it just to figure out what it is actually what it actually is. And this is an issue technically. Now, in order to get actual type while using the wildcards, we will have to perform manual type casting, which is always unsafe. And this is the biggest thing why we end up not using wildcards when we have to do a return type. Now, why we use wildcards? As we saw earlier as well, many times, that if we are reading something from the collection, that's the safest thing and that's the easiest, because wildcard will say, okay, anything whatsoever come up, I'm just reading it, printing it, doing nothing else. So it's very easy. Don't have to apply brains, just apply a wildcard and you will be good to go. Now, the biggest thing that we have to go about is that if let's say I would have used generics and I would have used that print list one. So print list one will say I need a specific type, and then I'm printing that specific thing with that type. So if I have a new list which doesn't have any type, right? In that case, if I just go and print the new list, it will not work because the type is not specified in the new list. While if I just do the same thing for print list 2, print list 2 was list like method having a generic type. That will work because obviously wildcard do not care about the exact type and it will work seamlessly. And that's the biggest and the only possible use case, not only, but yeah, the biggest possible use case for wildcards. Now, lastly, best practices, just a summary, that always make sure that you use generics for strongly typed classes and methods. Make sure that you use wildcards when the flexibility in type is needed, or especially you want to read the methods and all that stuff. As in, like, you want to read the things inside the specific method. Now, using the upper bound wildcards for read-only stuff and lower bound for write operations, such as putting up in the list and all that stuff. And always make sure that you avoid using wildcards because they are very risky. Typecasting, all that stuff can be required, which ultimately makes things very risky and unsafe. So again, make use of generics. That's pretty safe, pretty cool. But wildcards, avoid it. Lastly, see, the entire thing is enhancing type safety and flexibility and making the code reusable. That's the best case of using wildcards and generics. I hope you guys liked this Oops playlist, or Oops course, I should say, which covered little everything which you want to need for your LLD or anything whatsoever for your interviews in LLD. Cool. See you in the next video. Until then, goodbye. Take care. Make sure that we hit the like target of 250 likes. Next video coming soon. Bye bye.